with the introduction of our guest speaker.
A very warm welcome to the guest speaker, dignitaries, and participants for the second day of the online FDP on emerging trends in shipping. I take the privilege of introducing the guest speaker for session 4, Technology Integration in Shipping, Human-Machine Interface. Dr. Captain Suresh Bharadwaj has over 40 years of work experience, which includes 5 years as master and in command of various types of ships of the merchant marine. Subsequently, 25 years of multidisciplinary shore experience in senior and top management positions spanning the marine industry verticals of commercial operations, consultancy, academia, and research. He pursued funded doctoral research in Denmark and UK and a postdoctoral thesis funded from Greece. He is on the board of advisors of Svenborg International Maritime Academy of Denmark and on the board of research of Indian Maritime University. He is fellow of the Institute of Chartered Shipbrokers UK, fellow of Nautical Institute UK, and a fellow and warden at Company of Master Mariners of India. He is currently the resident director of Maritime Training and Research Foundation that is promoted by MASA, Maritime Association of Ship Managers, Ship Owners and Agents, a highly respected industry association, and heads its Maritime Academy at Chennai. He was the founder vice chancellor of India's first maritime university, AMET, at Chennai. His research papers have been published in high impact international journals like Safety Science, and he has been an invited speaker at many conferences in India and abroad. He is the editor of IARE Journal of Maritime Research and Development, an international peer-reviewed journal devoted to research in the maritime domain. He has also refereed and reviewed research papers for top international journals like Maritime Policy and Management, Journal of Navigation, and WMU Journal of Maritime Affairs. With this brief introduction, I now welcome the guest speaker to begin the session 4. Please, sir.
Thank you very much, Dr. Lakshmi. Thank you very much for that introduction. Very nice. Thank you for this opportunity to be here and interact with all the faculty of the maritime and few of them, I believe, non-maritime as well. But shipping happens to be an integration of all subjects. It's a perfect integration of all disciplines. And I think a reference to shipping will find relevance in in many areas as well. So the topic, my topic is on technology advancements and integration of technology in most of the operations that is happening, not only in shipping but non-shipping as well. But what does it take, and what happens with this technology integration? Is it delivering on what is expected? And if it is not, why not? So those are some of the issues. I'd like to share my slide. Let me just see if I can share my slides. What do I do? I have the PowerPoint open. Yes. And then your entire screen. Okay, your entire screen. But
Sir, you have to share your entire screen. There you get an image of your screen. Click on that, then click on share button.
Oh, okay. Yeah, your entire screen, and then click on the screen.
Yes, sir.
And then click the share button.
Yes, sir.
Oh, yes, okay. But my PowerPoint, where is my PowerPoint? Okay.
Yes, sir. Yeah.
Oh, you can see that, is it?
Yes, sir. We could see.
Okay, I'll put it on the PowerPoint mode.
Yes.
Yeah. Okay, so you can see this in the full PowerPoint mode now?
Yes, sir.
Okay, thank you. Right, gentlemen, ladies, thank you for this opportunity. And this presentation is on technology integration, which is happening in the shipping industry, and very specifically on this human-machine interface, because you will appreciate that whatever the technology that comes in, there will always be a human interface working on these technologies. And so, are we looking at this human-machine interface adequately in the shipping industry? That's what this presentation is all about. I am presently working with MASA, and this is the association of various big ship management companies in India. You can see like Maersk and Synergy and TK and Anglo-Eastern and Northern Marine, BW. Quite a few big companies are members of this association. And this association is running one academy in Mumbai, another academy in Chennai, and I am heading the Chennai academy. And we are mostly focusing on competency courses and civil database courses. Right. So the session now starts now and then ends at about 11:30, right? And
Yes, sir. It is.
yeah. Okay. So if I have to interact with the participants, I'll have to stop sharing for a while, and then we can interact. Yeah. Okay. So this technology integration, which is happening in shipping industry, this is a dramatic change, a very, very big change which is happening. The effect of this technological change and IT and OT, IT is information technology, but most of the processes which are happening on board the ship are based on operation technology, and this is comparable to that which is brought about by the change from sail to steam. The drastic change which happened from sailing ships to the motor ships and steam ships those days, that is a drastic change which is now happening from the traditional steam and motor ships to the highly automated ships which were happening. I mean, if you look at the typical shipping operations, every operation is now almost automated. Tank management, vessel performance, power management, propulsion control, alarms, cargo, everything is almost technology integrated. And you will appreciate, gentlemen, that technology always is supposed to be a great enabler. What is happening is these are the machineries on board, the main engine, data can always go on to the control rooms, and from the control room it can easily be passed on to the shore. So whether it is the ship's machinery or ship's operation, data, cargo operations, everything can be remotely passed on to people ashore. And so this technology is improving the operational performance, most definitely. It improves the productivity hugely. It optimizes a lot of operations, and this integration of technology is a differential advantage. It is a differential advantage which is used by shipping companies, advanced shipping companies particularly. And this information communication technology is today a strategic asset in integration of vessel plant data with business management systems. I mean, we don't have to look so far. If you look at some ordinary examples in our day-to-day life, we would like to go to a particular website because navigating that website is much easier than any other website. Yes or no? So, it has big advantages. It has very, very big advantages, and particularly when it comes to the shipping services today. The shipping service today, gentlemen, the ship has become totally non-existent in the whole gamut. of supply chain. Today a shipping industry is nothing but a small existing component in the global supply chain. The competition today is on the supply chains. Which supply chain is more efficient, more cheaper, more time bound? Whether it is a garment which is leaving the shores of Tirupur, or a garment which is leaving from Bangladesh, which is the one which arrives on the day of summer sale at the Walmart departmental store in New York. So the pressure is on reduction of cost. The pressure will always be a reduction on cost. Now, this is one thing which I think is specific to every industry, whether it is shipping or non-shipping. Today, if you see the shipping industry, last 3-4 months, the kind of profits which the shipping industry is making is huge. Whether it is containers, whether it is bulk carriers, containers particularly. The shipping is touching peaks after so many years of a lull. But the attitude will not change. But this is the same for every business, isn't it? Whether the business is making money, not making money, reduction on cost will always be there. Time compression, the compression of time, on-time deliveries, and which supply chain is able to transport the container faster. So time compression is a big pressure. Reliability of operation. Is the vessel going to sail on Monday morning 7 o'clock? Will the ship sail? So reliability of operations, standardization of operations, just-in-time delivery, flexibility and customization both at the same time. The customer's demands are ever increasing. You need flexibility, you need customization. Now, for a shipping industry to achieve this, or shipping industry or any industry for that matter, I mean, it is not only for shipping industry, these kind of pressures are there on any industry, And to meet these kind of pressures, the customers, the companies have to go towards technology. It is only technology integration that can deliver all this. Yes or no? Gentlemen, please feel free to comment.
Yes, sir.
Otherwise, but what happens in this process of the shipping industry? People fail to realize that the ship, which is the most important component in this whole supply chain, that is a safety critical industry. It is a safety critical industry. It is a huge ship which is out there in the middle of the ocean, exposed to all the perils of the sea and the perils of the environment. There are concerns for human safety. There are concerns for environmentally safe operations, and they have to coexist with service quality. No compromises on service quality. And this is something, because the ship is somewhere in the middle of the ocean, away from the eyesight, people forget that the shipping is producing the service with the ship as its core constituent unit. It is operating geographically, absolutely remotely, in a high-risk environment. People tend to forget this. And this balance, which is required, is critical. Today, if you see the advancements, what is a ship today with the technological advancements? Each ship, wherever it is in this vast ocean, it is just another node in the corporate intranet. Like in the corporate, you have one office in Hong Kong, one office in America, one office in Europe, and you're connected. Same thing is happening with the ships, boss. The physical gap between the land and sea is by virtual means. The gap doesn't exist. And there are so many softwares which are customized for technical management, for personal management. And the ship and the shore, today they are working as a very, very close-knit teams. So, technology holds a lot of promise. It holds a lot of promise. It's like a magic wand. But are there gaps? Are there gaps between expectations and the performance with technology? Are there gaps? Of course there are. Of course there are many, many gaps. Today, it is known of accidents and incidents happening, technology assisted incidents, technology assisted accidents. So what are the gaps? Why are these gaps there? And how these gaps are happening? What is the gap between the expectations of technology and what it is really giving? Huge gaps. There are many, many questions to ask. Why is this technology not living up to the expectations? What are the fundamentals of technology integration? What are the fundamentals of technology integration? Is it just a technology which is being inputted in the whole process, or there is some fundamental research and technology which is needed for this human-machine interface? What are the economics of technological change? Why is the shipping industry going for technology? Is it because it is delivering? Is it because it makes the life easier? No. No. What are these drivers for technology uptake? Are there issues in the design stage and they reflect poorly in the operation stage? You will find that the guys who are designing the ship, they have never seen a ship. They have never seen a ship, and they, from their perspective, they make wonderful and beautiful design. Beautiful design. They're all, architects, naval architects, and whatnot. They can only see ships operation on papers and modules and whatnot. But the operation of the ship, there is a huge gap between what a designer thinks and what it is delivering. I can tell you a wonderful example in one of the big shipping companies, Shipping Corporation of India. And first time Shipping Corporation of India was designing container ships. Container ships were being designed, and these ships were to be designed with gear, cranes. Cranes must operate the containers because they will go to small ports where the shore crane may not be available. So the people who are designing the ship, all Funda party, they asked from the operation department, okay, we are designing the ships, please tell us what is the average weight of the container. So the operation people don't know why are they asking this question. So they said average weight of container would be about 12 tons, average weight, So these design people, they said, okay, 12 tons, what we will do is, we will put the gear, let us add 4 tons extra. So they've actually designed the cranes for these container ships with 16 tons capacity. With 16 tons capacity, they were designed, ordered, fitted, everything. What was the problem? What was the problem? If you see the heaviest, the question which they asked the operation people was, what is the average weight of the container? Not what is the heaviest container. What is the maximum weight of the container? Instead of asking what is the maximum weight of the container, they asked average weight of the container. So operation people said average weight is 12 tons, but the maximum weight can go up to about 22 tons. So the ships were actually delivered. Fortunately, very fortunately, the cranes were together. So both the cranes, they were able to combine both the cranes and run it as a Gemini with 32 tons capacity. But this is what happens, the big gap between the design stage and the operation stage. What are the challenges then in operation and management of ships? But there are various potentials of technology as well. So this technology has very, very significant impact. It threatens to displace many of the practices that are characterized by seamen's art through ages. What are we trying to say? What are we trying to say? A simple issue like when the ship is being navigated, the navigating officers are required to keep a lookout. Look out. Lookout means look outside. Look outside if there are any ships, if there is any collision going to happen. Look out for navigational dangers. Now, the simple thing like lookout is not happening. Why? Because a whole lot of technology is now coming. You've got radar, you've got EGDIS, you've got this, you've got that. So people are not looking out, relying wholly on the technology. And please remember, this technology is only an aid to navigation. It is only an aid. You can't rely fully on that. There is a major case which has happened. There is a full-blown passenger ship called Royal Majesty. And this was approaching New York Harbor. New York Harbor, gentlemen, ladies, full-blown passenger ship, everybody on the bridge. They had to navigate one straight route from, I think, Bermuda to New York and coming straight entering into New York Harbor. One small wire to the GPS, you know the GPS which gives you the position. The one small wire to the GPS had come out, and that GPS was indicating a DR position, a dead reckoning position, not the correct position. But people assumed that this is the correct position, and that position was actually 70 miles off course. The ship is full-blown master, everybody on the bridge. And approaching New York Harbor, they are seeing, lookout is seeing the buoys. You have the buoy markers to enter the channel, and those buoy markers are not matching. And they say, no, this buoy, the light must be defective. Can you imagine what you are seeing? You are disregarding that. You have total reliance on the technology on which you are operating. And that ship, full-blown passenger ship, runs aground, approaching New York Harbor. Why? Full reliance on the damn technology which is there. No, you are not even believing what your eyes are seeing. This is what happens. And the situation becomes more and more complex when errors are introduced through this improper use. The automation, if it is not used properly, you are introducing errors in it. Automation and technology are decision support systems. The human element still remains prevalent. I will kind of stop sharing with this slide and like to get into a discussion mode with you. So far, so good, gentlemen. Is the message coming clear?
Yes, sir.
No,
Participants, post your questions to sir through chat box or unmute yourself, and you feel free to ask questions.
Mariners, I would like to ask the mariners, how many of you have sailed on Japanese ships and how many of you have sailed on Chinese ships? What is the difference on Japanese built ships and what is the difference on Chinese built ships? Engineers. Mr. Jerome.
Sir, hi.
Hi,
I had
Nitin.
a yeah, hi sir. Thank you for this topic is something which always grabs your attention. This topic is never ending. I had a question now. I want to know your opinion right now, since we're talking about integration of technology into shipping and the human interface also. What is your opinion on technologies, emerging technologies like Neuralink, which is trying to connect human brains to the computer? So, do you see that also have an effect in the interface with the machines and in digitizing the shipping industry also?
I know there is no limit to what the machine can do. There is
Hmm.
really no limit to what machines can do. But this it reminds me of how much of a human brain can you actually translate into a machine. A machine is a machine is a machine. Have you seen this movie called Sully? I am asking all the participants. Have anybody seen the movie called Sully? Sully. All the participants. This movie is about Captain Sullenberg, and this movie is about an aircraft which takes off from New York Harbor. This aircraft takes off from New York Harbor. Both the engines are bird hit. Both the engines are bird hit, and the pilot, played by Tom Hanks, he has to return back to the base. Now he turns around and he finds that there are two airstrips, New York and New Jersey, and he finds that he will not be able to make it without the engines onto this airstrip. So he lands onto the Hudson River in New York, the Hudson River. True incident. He lands on the Hudson River, beautiful landing. Beautiful landing on the water. All passengers are safe. All passengers are safe. And after the passengers are disembarked, this pilot, who is a hero, now the movie starts. The movie is not about his landing onto the river. The movie starts now. It is about incident investigation. The bloody insurance fellows, they come back and say, no, pilot, you could have landed on the true strips. The kind of technology which is there in aircraft today, it is, I mean, fly by wire. It is absolutely fly by wire today. I mean, you don't even need to touch your anything. So they said, no, you could have landed. The aircraft is spoiled. Aircraft is totally gone. Who is going to pay for it? And they are demanding, why did you not land on the strip? Why did you land on the Hudson River? So this man is very upset, he and the co-pilot, and they asked, how did you decide? No, we have simulated this, from the black box. You take all the data and then you simulate the whole conditions into a simulator. And then they say, we did it on the simulator, and on the simulator you can land. Simulator, when you simulate, you're already having a lot of data with you. Okay, he said, okay, please tell me on which attempt in simulator you were able to do this. You know what they say? 17th attempt. After having all the data with you on a simulator, you are landing it on the 17th attempt, not the first attempt. Then he goes on to say, see, my aircraft has taken off, both the engines are bird hit. Give me 2 minutes to decide. Should I land? What should I do? Give me 2 minutes to decide. So the investigation team said, no, 2 minutes is too much. You should be able to take your decision in 40 seconds. So he says, okay. The same team who did it beautifully, landing on the 17th attempt on the simulator, please incorporate 40 seconds of delay. And that is the ending. That these guys on the simulator, with 40 seconds of delay incorporated, the plane does not land. The plane does not land. I mean, it just goes to show that whatever the technology you have today, whatever, the man who is there in it, you call it a sixth sense, you call it his experience or whatever, he is an absolute asset. Absolute asset. Very, very difficult. We're talking about autonomous ships. why they very recently there was some news that there was a autonomous bus or a train which went and banged somewhere and created a major accident. So they are trying this out everywhere. Particularly in shipping industry. Shipping industry there are a lot of accidents keep happening. You know what they say? What is the main cause of accidents? You ask any person from shipping. Sir, what is the main cause of accidents? Human element. 80% of accidents are happening because of human element. So you remove the human element and make the ship very autonomous. So this is what I want to develop a little bit more further. And looking at technology in the shipping industry through the lens of incident investigation. Through incident investigation. And this is an absolute myth. Can I continue?
Yes, sir.
Okay.
Excuse me, sir.
Yes.
Sir, actually, you asked a question about the difference which you people feel between Japanese built ships and Chinese ships,
Yes.
right,
Yes.
sir?
Yes.
Actually, I'm the wife of a chief engineer. I happen to sail on as a, what to say, a company only
Yes.
in a Japanese ship named Pacific Innovator.
Okay.
But my husband, who worked with NYK for a long time,
Yes.
used to say that Japanese ships are very much, automation are very good. Even the machines will give, what to say, the falls which you have in the ships are very less
Yes.
than Chinese ships.
Yes.
I hope that was the answer which you were
Yes, madam.
expecting.
Yes, absolutely right. Absolutely right. If you see the Japanese ships, first and foremost, the automation itself is very little. Very little automation. And whatever automation is there, it works beautifully. It works beautifully. Why? And there is a whole lot of standardization. Whole lot of standardization. You go from one sister ship to other sister ship. The machinery are exactly the same. Exactly the same. There are no different manufacturers, different equipment. It takes a lot of time for people to familiarize with the different equipment. Why is there no standardization in shipping? So that is a very, very important point which is there in the Japanese ships. Very less automation. Whatever automation is there works very well, and there is a whole lot of standardization. But when you go to any other cheap Chinese built ships, you have a lot of automation. Different technologies who are selling technology cheap. They will put their machinery, and it will not work, and this gives you a lot of stress. It gives a lot of stress to the people on board the ship. And this is something which I want to highlight, this man-machine interface and how it is bringing the stress. Today, if you see the slide, can you see the slide, ladies and gentlemen, on the screen?
Yes, sir.
Yes, sir.
Yes, sir. Yes, sir.
This is the shell model. Today's work environment, ladies and gentlemen, is not a man working alone. No. The liveware, the person, he is interacting with a lot of hardware. Yes, lot of machinery. Hardware is nothing but the design of workstation, the look and the feel of the machinery. He is working with a lot of software, which are checklists, manuals, computer programs, layout, maps, software, a lot of software. The liveware is working in an environment. The environment of the ship, the engine room, the pump room, the ship, the external environment, the internal environment. We are talking about vibration, noise, temperature, visibility. And we are also talking about an environment of the company culture. Company culture. A person sails on a company like Shell or BP, the safety culture is very high. Or he sails on an ABC company where the safety culture is very low. Does it affect the man's work? Of course it does. So this person today who is working on board the ship and interacting with the hardware, interacting with software, interacting with liveware, interacting with environment. This is the working model today. And normally in the shipping industry, when a person joins the ship, he has to take the ship from place A to place B. No questions asked. Whether the ship is good, machinery is bad, he has to take the ship from place A to place B. Period. So this man, he is working with a lousy hardware of the ship. He is working with a lousy software which is provided. He is working in a lousy environment. Now this man who is making these things work for you, taking the ship safely from place A to place B, is he a problem or is he an asset? Is he a problem or is he an asset? So this model of Shell is typically used in every transportation industry, particularly marine transportation. And here we are talking about the problems of interface with hardware, problems of interface with software. You know, if you look at an example, the interface of ECDISC is nothing but the electronic chart display. This is a major revolution in technology. People used to work with maps and charts manually. Now it is everything on a computerized system. Major change. Now the master had several problems allocating functionalities responsible for the route checking and safety parameters. So what is the problem? Is the man the problem or is it the machine the damn problem? Why should it not be standardized? You know, you look at the aircraft. Fortunately, in aircraft, there are only two manufacturers, Boeing and Airbus. So, and a pilot who's sitting, once he puts up his left hand, the switch of the left hand is exactly the same switch everywhere he goes. But not so in shipping. There is no standardization. There is no standardization. So, the look and the feel is totally different. Hardware problem. The enclosed space entry procedure did not specify the rank of crew responsible for preparation of permit to work. This is a procedure, a software problem, creating confusion. You are telling the people to work with procedures. The procedure itself is bad. Now that procedure is creating confusion. The problem is with software or the problem with the ship staff. There are excessive number of alarms. The crew started acknowledging them without verifying the source. You ask any engineer, he will say, sir, if the alarms were much lesser, we'll be much happier. So the problem is this. That the fundamentals of technology integration is never looked at. Technology, gentlemen, ladies, is not an external force. It is not an add-on. It is a complete rich mix between human action and technology. The technology-centric framework defines a process, organization, everything to be looked at together. Not an equipment which is placed on board. Oh, I have to place an ECDISC on board the ship. If there is an ECDISC, which is supposed to be an electronic chart, which is supposed to face the front, no, there is no place in the front, I will put it on the side. Why? No. Fundamentals of the technology integration is not looked at. It is very dangerous to place more importance on workers' tools than on workers themselves. Okay, since you are all from the maritime institutions, and teaching mariners to be on board the ship, please remember, the mariners who you are teaching this is a competency-based environment. They have to learn to do, not learn to know. There is a big difference. And one very important, ladies and gentlemen, one very important distinction between an ordinary engineering college and a maritime institution is that the faculty who comes in a maritime institution has to have an industry experience. Yes or no? You have a master's ticket, you must have a chief engineer's ticket. But you go to any ordinary engineering college, even why ordinary engineering college, even IIT here, the guy who's bloody teaching there has never seen an industry also. Yes or no? Now I am asking you this question as a maritime trainer. There is a big dilemma. Merchant ships are now so automated. Merchant ships are now so automated that only little skills are demanded of those who control them. The automation is very high, so we don't need very high skill. Is this correct? Or the merchant ships are so complicated that we want people who are highly skilled to fully comprehend the complexities. Which statement is right? Which statement is right? This is an actual dilemma.
First statement.
First statement is right, that the merchant ships are so highly automated that we don't need highly skilled people.
Yes, sir. People working with Japanese ship, they are feeling more automation and less skills are needed. What I see, if we go
Absolutely.
in ships
Yes.
which I mean Indian companies or more troubles. I mean Chinese made ships, for example, they face more troubles and they need more skill to overcome those troubles. Every day they have problems. Every day they should
Excellent.
find why boiler is, why this line is leaking, how to arrest this. Like that, they need more skill. That's what I feel.
Excellent. Absolutely right. Absolutely right. Absolutely right. If the technology is working fine, no problem. You need little skills, but the whole world is not Japan, man. And the shipping industry, if you see the shipping industry, this is a worst case scenario of globalization. The worst case scenario of globalization. You could be a very rich American and or a Greco and you're owning a ship and you flag it out in Timbuktu. Why are you flagging it out in Timbuktu? Because you don't want rules to be there. You want somehow the ship to run. No focus on safety, no focus on technology, nothing. So both can exist. This is the problem today. Both can exist unless and until there is a customer pressure. Unless and until there's a customer pressure, like the vetting inspections, like the oil majors, they are putting the pressure today on all the tanker industry that you have to raise your standards. So if you want the ship to have business, you need to come up to that standard. That is the best pressure. Otherwise, rules, regulations, and all make no difference. So this is actually a dilemma. There is a de-skilling theory that seagoing people are no longer expected to possess high caliber diagnostic skills. Upskilling thesis, the knowledge and skills of workers is a dominant source of productivity. There are both these theories which are existing and causing a dilemma. If you look at the airlines pilots, they're not even graduates here. Why? The technology is beautiful, but in the process, what is happening is they are forgetting even their skills. Do you realize that in the airline sector, they have made it mandatory that the pilots must use their joysticks, their hands on, because they have forgotten that how to operate the plane with the joysticks. So it is mandatory for them that they have to remove all the automation, go back to your basics and operate. This is what happens. This is the fundamentals of technology integration, gentlemen, ladies. When the technology systems are there, they are machines. Their hardware interface is there, software interface is there, instructional support is there. But when it is interfacing with man, you are talking about his sensory perceptions, cognitive, psychomotor skills. So there is an issue of capability. A machine, you can put any data in the machine, it will operate. But is the man capable? Is the man capable? This demand versus capability has to be very, very closely balanced, which happens on the Japanese ships. And the outcome will fall on the performance, on the attitude, on the acceptance. So there is a proper theory, there is a proper skilling theory called the SRK theory. SRK, not Shah Rukh Khan. SRK is skill-based behavior. Cognitive activity is a continuum from an intuition, de-skilling to upskilling. Both of them are there. It's a continuum. When everything is fine, open sea, no problem, automation working, great. But it goes from skill-based to rule-based to knowledge-based. If you have an abnormal situation or an emergency situation where the automation is not able to, like the case of the aircraft landing, you have to go back to your instincts, your basic knowledge, that is the theory. So this human factors, now if you look at it from the incident investigation perspective, we are going into heavy fundas. We are going into the shell model, which we have already seen, which is the nature of work. James Reason model, this is very well known in the shipping industry. And of course, we are going into the Rasmussen's taxonomy of errors. Why is the error created? Why is this error created by a seafarer who is certified, who is competent, who is experienced? Why does he create that error? Ladies and gentlemen, this is the Swiss cheese model, which is very, very popular in the shipping industry, but least understood. You know, the understanding of Swiss cheese model in shipping industry is what? These are barriers. These are defenses. Defenses are barriers for an accident to happen. All right. They say that, okay, this is a PPE, personal protective equipment is a barrier. Supervision is a barrier. Training is a barrier. Permit to work is a barrier. An incident will happen only when all the 4 barriers fail. So what the shipping industry says, if 1 barrier is failing, at least 3 barriers are there. If 2 barriers are failing, at least 2 barriers are there. What are we saying? Are we saying safety by chance? But this is the exact understanding of shipping, and keep blaming the seafarer. This model actually talks about an active failure, an unsafe act, and unsafe condition. You don't have a major accident out of the blue. Oh, no, sir, everything is working fine, but today we had a fatal accident. Nothing happens like that. Nothing happens like that out of the blue. You have latent conditions lying in the system for a long time. People don't bother. Why? Because nothing happened. Because nothing critical happened. This is what is shipping industry. 4 out of 5 times that poor seafarer is making things happen. Nothing happens. He gets a pat on the back. Great job done. 1 time, problem. And the whole focus is on this 1 time. The whole focus is on this 1 time. Why this accident happened? Why this incident happened? And blame the seafarer. Nobody looks at why the things did not happen. Why? Chalta hai, chalne do, why open? So, gentlemen, ladies, very important slide on the screen. This concept of human error is not there. The concept of unsafe act has shifted from being synonymous with human error to a notion of deviation from performance. There is no human error. The person has deviated from expected performance. That's all. Why has he deviated? Because there are conditions. What are these contributing factors which make him deviate? When you ask this question, then you direct the analysis upstream from the worker to the process. You are also considering a lot of barriers. I've got a barrier of training, I've got a barrier of permit to work, I've got a barrier of personal protective equipment, I've got a barrier of... In spite of all these barriers, why have these barriers failed? Why have these barriers failed? Because there are latent conditions which are lying in the system well before the system. We are just fortunate that nothing happened. Gentlemen, very important slide. This human error today is not the cause. It is an effect. It is an effect of all the causes which are lying elsewhere from the ship. It is not the seafarer. And the safety science looks at the shell of a very hybrid model of the shell model and the James Reason model. This is a hybrid model, a shell model and a James Reason model. And when you combine this, what we are looking at is an event and causal factor chart. One event leading to another event. Seafarer is fatigued. He overlooks the alarm. There is an overflow and there is a pollution incident. So this substandard act will be there. Yes, he is fatigued. But why is he fatigued? Don't you ask this question, why is he fatigued? There are substandard conditions. Substandard conditions. We have to go one more step up. How did the condition originate? And one more step up. Which is the root cause? Why did the system allow this condition to exist? And gentlemen, ladies, this is the root cause. This is the root cause, not here. These are only symptoms. This is the root cause. And in the shipping industry, very, very pathetic to say that we have never looked at the root cause. Sir, ladies, is shipping industry rocket science? No. Why is the shipping industry not improving? I came across a wonderful paper from World Maritime University, ladies and gentlemen. Wonderful paper from World Maritime University. When did the Titanic happen? 1912. When did Costa Concordia happen? 2012. There is a proper research paper from World Maritime University. From Titanic to Costa Concordia, 100 years of no lessons learned. This is what is shipping industry. 100 years, no lessons learned. We refuse it. If you look at the safety science, this is a DNVG, a loss causation model. There is a substandard act. These are the immediate causes. And this immediate causes, because of the lot of barriers, some accidents may not happen. But one time this accident happens. Because of this, these are only immediate causes of seafarer making a small mistake. There are basic causes and there are root causes. Root causes are there. So when you do an analysis of incident, you go to the root causes. And when we look at a technology integration, you realize that there are a whole lot of problems that lie here. Why does the error happen? This is the Rasmussen's taxonomy of errors. This unsafe act which the seafarer has done, it could either be unintentional or intentional. Intentional, gentlemen and ladies. If it is unintentional, it is a slip or a lapse, attention failure, memory failure. Many a times it is intentional, purposeful violation of the procedure. Purposeful. It could either be a mistake in planning or violation, conscious violation. Why? Does he want an accident to happen? No. Nobody in their sane mind will cause an accident. Nobody. But there are pressures. There are pressures to do this work fast. Time pressure. Okay, if this job is requiring 1 hour, I finish in 30 minutes. Nobody asks the question, why you finish in 30 minutes? Instead, he gets a pat in the back. Hey, great job done. He has definitely violated a lot of areas. And this builds up. This builds up in the process. Nothing happened. Chalta hai, chalne do. Please remember, these violations are not to commit a valvolent act, but just to get the job done. This is the loss causation model. The loss happens because of the system failure, the organization failure. That is the root cause, which causes. And so when we do an incident investigation, we must go back. There is no point in blaming the poor seafarer, no point. But we always kept on like that. And because of that result, the poor seafarer who has gone through a lot of stress on the ship, taking the lousy ship from place A to place B, he has gone through a lot of stress. And with the kind of inspections and surveys and the pressures which he's having, he goes through a lot of stress. He is not able to work more than 3 hours, 3 months or 4 months on board the ship. He signs off. And once he signs off, he has to go through more and more training. Why? Because all the mistakes which is happening, you are identifying the bloody seafarer as the cause. So what is the corrective action? Training and training and training. Big mess. Big mess. Conscious decision by the shipping industry. Look at this slide. The human performance. The human performance on board the ship is affected by so many factors. The ship factors. How is the ship? There are external influences, the environment, as we said, the shell model, the organization on board, shoreside management. Shoreside management, what kind of management they are doing, practices. A simple thing like today, not relieving a person on board the ship. There was a typical case. Somebody was telling me a pumpman on a tanker was supposed to sign off. And a person works on board the ship for his family, and if he is not given his relief on time, how his condition will be on board? 2 months overdue. The ship comes to Rotterdam. The pumpman finds that his reliever has not come. He goes and sleeps locks himself in the cabin, sleeps. Everybody on the ship thinks that he has already lined up the cargo, and they start loading. The moment they start loading in Rotterdam, the cargo is going out to sea on the other side. Why? Because the pumpman has not got his relief. He's said, hell with bloody everything. Can you blame the pumpman for this? Can you blame the pumpman for this? Please remember, this human performance is affected by shoreside management. So many factors. When we are talking about human performance, what are we talking about? His competency, his attentiveness, his alertness. As far as competency is concerned, we have got a beautiful STCW convention. Standards for training, certification and watchkeeping. Experience is covered, education is covered, training is covered, aptitude is covered now. Soft skills are part of STCW 95. Then we talk about his attentiveness, workload, lack of motivation. Of course, there is lack of motivation. In this case of pumpman, total lack of motivation. But why? Distractions, alertness, because of circadian rhythms, sleep cycles, stress, fatigue, rest. Why? Nobody asks the question why. And this human element who is there in the center of it, he has got so many factors affecting him. You don't have the time to go through all this, but in essence, you would have realized that when we talk about complex systems, the human error does not emanate from individual. It is a byproduct of ever-present latent conditions. The triggering error by the seafarer is only the last in the network, remotely related to the accident, but we conveniently blame the seafarer. This is the accident model. There is a routine service, build-up period, critical period, and then an accident happens, not out of the blue, not out of the blue. And there is line management, there is operational, the organizational, and technology integration plays a very, very big role. These are the barriers, gentlemen, ladies. For every threat, there are preventive barriers, like permit to work, training, supervision, PPEs. They are all preventive barriers so that the incident does not happen. If the incident happens, then there are mitigating barriers so that the things are under control. SOPAP and fire extinguishers and this, that is there, so we have preventive barriers, we have mitigating barriers, and they are all controlled by this management system on top. This is something we need to realize. So far, so good. So far, so good. Having understood this theory of incident investigations and accidents happening on board, now I have got 30 minutes more, and I would like to dwell this 30 minutes on the technology part of it that I was mentioning. What is the economics of technological change? Why do we need to have technological change? This is because volatility resulting in short-term relationships. Technology keeps changing frequently, very, very frequently. New technology is available long before the expiry of the last one. There is a difference between early adopter and late adopter. Should I be the first one? Should I be the last one? Who is going to take the risk? It may not always be profitable. Who is going to invest in innovation? And the worst is the split incentives. What is the split incentive? What do we understand by split incentive? Ladies and gentlemen, if you look at the shipping industry today, it is far, far away from what it was before. You have one ship owner running his own ship. No. Today you have a ship, one ship. The ship owner is sitting in Greece. He has given the technical management to some company in India. The Indian company has given manning to some company in Philippines. The ship is under Vanuatu flag. The charterer is somewhere in Germany. The cargo, there are so many interests. The class is from Japan or Korea. So there are so many interests in shipping. There is only one ship. Ladies and gentlemen, there is only one ship. But there are at least 15-20 different people who are looking at the ship. What is in for me? The owner says, I have invested 10 rupees, I want 15 rupees. The management company says, my budget is so much, I want to save so much. So each one is looking at it from a different perspective. And this is called the split incentive. And this is what is the worst case scenario of a globalized industry. Worst case scenario of shipping. The progress in technology gets hampered. Who should pay? Who will pay for this technology? Because today the technology which is coming in, gentlemen, ladies, I have the latest marine policy, September issue of Marine Policy Journal. Ladies and gentlemen, you must read these journals, which are top class. So the latest issue of Marine Policy Journal has got a paper which is quantification of involvement in the IMO making of rules and regulations. They've actually quantified, once again from the World Maritime University. They've actually quantified that this IMO, which is there in London and which is making rules and regulations for the shipping industry, who has got more pressure? And they have found out that there are only 20% of these big companies and big countries who are having these big companies. They are doing 90% of the work in IMO. 90% of the work in IMO is getting done by this. And about 60-70% of the industries are not even participating. Where do you think India stands in IMO? You can guess. So the point is, these developed countries like Norway, Denmark, they are high on technology and they are making their presence felt in IMO. They are not selling technology. No. They don't sell technology. They sell environment. They sell safety. But to reach those standards of safety and environment, you have to go for technology and expensive technology. That is the big game which is happening in shipping industry. So the progress gets hampered, and who will pay for this technology? Many people say there should be no cure, no pay basis. The drivers, what do you think are the drivers for uptake in technology in shipping industry? Is it competitive advantage? Is it efficiency? Is it compliance with rules and regulations? Is it customer pressure? Most cases, it is compliance to regulation. It is the regulation which says, no, not technology. You have to reach this level of energy efficiency. How do you reach there? Left to you. Please go for technology. So whenever automation can be shown to be greatly improved by safety and environment protection at an affordable cost, that there will be inevitable pressure. And this is what the technology manufacturers are doing. I am able to meet these rules and regulations at affordable cost. So he's bloody selling technology. So this is what we need to understand, ladies and gentlemen. Is safety being used as a ploy to push in more technology? And this enthusiasm is getting weighed against the economic logic of returns on investment. The shipping industry is only just understanding human factors. This is something which is just not understood in the shipping industry. Oh, seafarers have no choice. This is what you please remember. Seafarers have no choice but to cope with the situation of that given technology, lousy technology, bad technology, good technology. You, Mr. Seafarer, you have to deliver ship's performance. Now to do that, he has to go through tremendous stress. Do you know what is the major cause of fatalities on board in shipping industry today? Take a guess. What is the major cause of fatalities on board the ship? Anybody? Any guesses? What is the major cause of deaths happening on ships? All quiet.
Violating safety
Sir.
norms.
Violating safety norms is the major fatalities?
Sir.
Yes, sir.
Sir, I am Hari.
Yes, Mr. Hari.
Sir, actually, I am working as a manager in Cochin Shipyard Limited. Currently in inspection quality control section.
Excellent.
And actually, as I am going through very promptly the class given by you. And now the accident scenario you told, no, sir. The thing is actually in ship, in a vessel, when we are proceeding for a trial, we are always manning the engines around the engine room, so that if any abnormal sound, any abnormal noise, any abnormal characteristic comes into the engine room, we will notify and we will attend to it, or we will elevate to the higher level, so that the OEM will take care of the scenario, so that a major accident may be stopped. This is our quality control, the function on board the ship during the sea trial. When we are going for the sea trial, this is our major work, sir. Whenever the temperature of the bearing increases, we immediately note it down, and we inform the OEM or the production team. So this temperature is going high. What's the reason of that? And so that the OEM will come to the place and site, and he will address that.
Excellent.
And in this way, we avoid the accident, and maybe it will improve the system. Correct. Actually, we have come across similar situation.
How many OEMs are there? How many OEMs are there?
Sir, actually, this depends, sir. Inside the ship, there are many systems. When you are going for a trial, all OEMs will come with us. comes with us. Many OEMs, and depending upon the system, each and every OEM will have their own check. Whenever they don't see it, we will identify and we will inform them, so that they clear that issues promptly at that time itself, so that no development, no degradation might occur.
Exactly. So if you're looking at from the design stage, the aspects of safety and environment are best addressed in the design stage, not in the operation stage. Best place to address safety and environment is in the design stage. Now, when we are talking about the design, how many different manufacturers and how many different equipments are there? Tremendous. Why? And suppose if all this has to be integrated together into an automated process, what does a shipyard do? What does a shipyard do? He will take this automation from here, he will take that automation, we can only mix them together and give you. Yes or no? Now the problem is there is no standardization. There is no requirement for standardization, first and foremost. So, this is where it lacks. Today, I can tell you, the nautical side, IMO has taken this decision that in every equipment, why should there be so many manufacturers? Yes, okay, you have different manufacturers, but there should be something called an S mode. S mode is standard mode. I think everybody must understand this concept, that every equipment must have a standard mode. Standard mode means the look and the feel of the equipment between different manufacturers should be the same, exactly the same. Like when we're talking about bridge equipments like egg disc and or even in the engine room also, there are different equipments which are there. It takes a lot of time for a person who's changing from one ship to the other ship to familiarize himself with the equipment. Many a times these bloody manuals which are made by these equipment manufacturers, that is not standardized. And most of these equipment manufacturers will give you a manual where they will not tell you how to find faults. They will tell you about operation. Because if there is a fault, they want to fly down their own bloody engineer, service engineer, and then there will be a separate charge for it. All this bloody thing happens, man. Yes or no?
There are few answers in chat box. Pandian says stress could be one of the reasons for the fatality.
Trust, okay.
Not trust, stress.
Absolutely. Stress. Absolutely. I think you have hit the nail on the head.
Yes.
Absolutely.
And one more answer from Mr. Gopalakrishna. User interfaces not consistent and non-standard.
Absolutely. That is very, very true. I appreciate these answers. Not standard, not consistent. That is why we said that there is a requirement which is accepted by the IMO, that there is going to be an S mode, a standard mode. Standard mode means the look and the feel of all equipment across the manufacturer is going to be the same. And somebody said stress. Yes, mental health. Today, most of Krishnendra Das, how are you?
It also require inline training also. It is very fine, sir. Fine. How are you, sir?
Good.
Good morning, sir. Sorry, my net is I'm in campus. Very difficult because campus logging, so no power. I am trying to use my mobile. Very difficult. So inline training also very. So as per your very valuable input, inline training very important, because as you say, different companies, different designs are there. So it is very, very useful inline training. Yes, it is very complicated, but it is also required, sir.
No, sir. I want to go one step ahead. Why are you not standardizing the equipment? Why should there be different equipments? Because there are different equipment, seafarers there, usko train karo. Keep training the seafarer. Why can't you standardize the damn equipment? That is what is much better solution. नहीं हम लोग तो अपना कुछ देखेगा नहीं. Mr. Seafarer, तो आपको बहुत stress होता है. I will give you one psychologist and you go through a stress training, and so that you become more resilient. अरे what is causing the stress? हम लोग उसको कुछ नहीं करेगा. This is the issue.
It
Yes,
is a part
yes,
of
mental
our
health is a
business,
big
sir.
issue.
Also, it is a part of business.
Absolutely right. That is what I'm saying, that if you see the latest paper from this marine policy, very clearly it is mentioning that the technology manufacturers and the regulators, normally they go hand in hand.
Sir, sir,
Yes.
sir, sir, I wish to point out that, sir, actually, respect to the accident or incident for the ship, the thing is actually, man, quality control man, my our sequence of stage of inspection will be like that. Do before the sea trial, we will be completing for each and every system harbor acceptance test. Every system involved in the engine room and room,
Yes.
everything. And once after the
Yeah.
completion, we will go to that. After satisfactory completion, only we will go to the sea trial. Trial readiness, we will get the letter from class societies like Indian restaurant and DNV shipping. DNV class is there, ABS class, and when these agencies they will give the paper, the permission letter for sea trial, we will pursue trial. So after getting the letter, we will invite all the OEM concerned, so that the pending trial, that is a sea acceptance trial, that be conducted on board the ship during the sea trial only. At the time, all SAT documents we will consolidate as a QC point of view. We will record all the tests and we will document it. So none of the test will be left out. None of the test will be left out. So the accidents, the scenario, the probability will be less, because all the test of the equipment will be attended in a good manner, so that nothing will be left out. If any like glitch or any malfunctioning comes, we will identify through the time and we will point out. We will give it as a comment to the OEM. So OEM will attend to that in a prompt manner, so that the accident scenario is very much very much less. And
Correct. Okay. Now you have talked about a scenario which is a sea trials. The whole focus is on working of that equipment and for that thing. Please ask next time any of these surveyors who come, IRS, ABS, Lloyd's, what training they have gone through on human machine interface. Just ask them. Do you have any knowledge of what is human machine interface? They will be certifying. OEM is there. He has made an equipment. He has made an equipment. They will go and certify the equipment. That is all they know. But the equipment, does it work on its own? This interaction of human machine interface, who knows? Ask them. Ask any damn engineer. Zero knowledge. Zero. Is that important or not? And you are talking about a scenario in a design stage where everything is beautiful and everything is focused on that area, wonderful sea state, but the actual happening on board the ship, which is there and out at sea under so much of pressures and working of cargo, this, that, there are different conditions. And different conditions, the thing must work. So I'm not saying that that this needs to be, we need to go 2 steps or 3 steps higher in our working in the shipyard itself. Tell me, you coming from a shipyard, do you have anything called STCW? Do you have any work method or work procedures mentioned for every level of work in the shipyard? Who is doing what work? Who is certified for that particular work?
yes, sir, we have SOP, standard operating procedure. We have standard SOPs, standard operating procedure for each.
No, I'm talking about each and every work you have got. Yeah, but I'm talking about the standards of training, certification for the people, like what we have in the ship. For every ship, for every level of work, what he's supposed to know, what he's supposed to deliver, that is a beautiful document. I have been to this Larsen & Toubro shipyard so many times. And the general manager of Larsen & Toubro here, Mr. Rishikesh Narsimhan, he keeps telling me he's a marine engineer. And he says, sir, what we have an STCW on the ship, in the shipyard, there's nothing. Nothing. And he keeps breaking his head with the people who are working there. So yeah, yes, sir.
Sir, actually, sir, as your the statement, actually, we actually in our shipyard we have recently built on ship. It is a high voltage electrical propulsion ship, 3.3 kV it operates. And
Okay.
prior to building the ship,
Yes.
and myself and other teams, other colleagues have been sent for training for the high voltage training on board the ship at Bengaluru.
Okay. Okay.
And
Okay.
our shipyard is actually, whenever there is a capacity updation or a technology transition to be done
Yes.
for undertaking any different kind of vessel, and our HR department is fully they are giving training to us. So yeah, that part of training we are much satisfied, because before
Okay.
undertaking, sir, high voltage, as you said, no, sir. High
Yeah.
voltage is a different that we cannot enter the switchboard room during
Yeah.
the operation time.
True.
It is advised not to enter into the such very
Yeah.
high voltage area.
Yes.
If we
Yeah.
are entering,
Yeah.
also, we must have some like arc flash shoot many things. When you
Yeah,
shoot,
no, we
we
are
have
doing
to
we are doing high voltage management level training 5 days, and we have got a simulator. We have got a simulator designed by ABB in our academy. We are doing this training for the operation staff. So what I'm trying to say is, if you look at this slide, can you see this slide? Research has pointed out that there are issues in design stage. The system users should not be add-on. The whole process of the engineering design and the functional design must be integrated together. It is not about making one equipment sit here, another equipment sit here, join together. No, we have to integrate the process, the man, the machinery all together and look at it. And that is totally lacking. Limitations on the type approval of system figuring by class may not be capable. No class is capable. There is variation in the design manufacturers. Then there is a need for standard mode.
Sir, actually, I would point another scenario. Actually, during the time of checking, as you said, the type approval. Whenever a major system like propulsion motors and engines and diesel generators, when they are installed in the ship, my first work is to take the type approval of the engine, and it will be signed by the class authorities, and the serial number will be stamped in the engine base plate. I will check on my own, because my chaps, my quality inspectors will also be around me, and we will check whether the certificate is true, whether the certificate stamping serial number and the site serial number is matching or not. We will find at that place itself. After that only we will clear that this engine can be allowed for allowed for charging or operation. So that fundamental checking will be finally done. If any change is there, I will put a mail to them so that a design will take in. So as our shipyard is concerned, these are very systematically arranged, sir. The design will take all the approved, because
Agreed. Mr. Hari, I think you will have a good run in the next session. In the next session, we have Mr. Rishikesh Narasimhan, who is the general manager of Larsen & Toubro. He is coming, so I think he will be able to have a good engagement with you.
Yes, sir. Thank you.
And my last slide before I end, the last slide before I end. The goal of technology integration and what we are talking about human-machine interfaces, it addresses the objective of enhanced performance. And when we talk about enhanced performance, it is a rich mix of the shell model. The hardware, the liveware, the software, the environment, they must all gel together. The safety must be taken care of. And user satisfaction, like distinct example, Madam also talked about user satisfaction in Japanese ships and not so much in Chinese ships. So if these goals of technology are met, then of course that is when the human-machine interface is going to be highly successful, and that will deliver. So I will stop sharing, and we still have got about 5 minutes for any kind of discussions and comments. Please feel free.
So during class itself, there were many interactions. Many interactions.
Okay.
Participants,
Mr. Balaji, how are you?
Balaji sir,
Fine,
you are
fine, sir. Thank you,
muted.
sir. Fine, thank you, sir. How are you, sir?
Very well, sir. Thank you so much.
Sir, Gopal here from Mumbai Port campus. Is this with the increase in automation, a lot of information is available, and is it one of the reasons it's beyond human consumption? The rate of information coming is too much, and is that is another reason we have to be filtered appropriately? That's a part of human interface, HMI.
Absolutely, absolutely right. Very well pointed out. There is an overload of information. Many times there is an overload of information which the human cognitive limitations are there to decipher it. So this is what is an important part which you pointed out. Yes, too much of information load. Like ask the engineers, there are so many bloody alarms. This alarm coming there, that alarm is coming there. If the alarms are much lesser, it is handleable. No? Sure, sure. Thank you.
Thank you.
Sometimes unable to locate which alarm is last one.
Very good.
So finally, though we have many kind of artificial intelligence, machine learning, everything, it is the human who has to coordinate properly for smooth sailing, for efficient operation, right, sir?
Absolutely, madam. Absolutely, madam.
And for which you are suggesting we need to get training and we have to keep us updated.
Yeah, the focus on this human machine interface is like if you see the cell phones today, the 3-year-old, 5-year-olds, they are able to. Why? Because there is a whole lot of investment by the technology manufacturers. Who the main subject they take, like in India, the main subject we take is engineering and doctors, and in Norway, Denmark, and all the choices of subject is psychology. They're taking up psychology only to understand how a man thinks and incorporate that into the technology so that by instinct the children are able to navigate.
Yeah, yes. So in modern world, irrespective of the domains, fields, we need to have psychology as a subject or some kind of mental counseling. Then and that's it.
Absolutely, that understanding of this technology not working alone and the man working with it, understanding the capability of the mind and matching that up together, that is the key.
Yes.
Sir, one more question regarding the non-standardization in the industry. Is it, you pointed out one reason that in the name of safety, technology providers, they keep selling in conjunction with whatever regulators and all that. But is there any other reason, like the system designers are not doing elaborate work to specify clearly what is expected from the OEMs and all that? Is that another reason or it's not there?
See, that is where it happens that if you have a technology which is going to deliver you on compliance to environment and safety at an affordable cost, you will sell. Because the guy who is buying it, the ship owner, he is buying technology not for improving things. He is buying because that bloody regulation says, yeah, I have to somehow comply with this regulation, let us buy something and put it on the ship. He is not bothered whether how the person on the ship is going to operate with it. Unless he is the own ship owner, like most of the Japanese people. When they think that the ship staff is their own and the ship is a berth and they are the ones who will do, so they are the ones who take care of these things. But if the split incentive, the structure of the shipping industry is so bad. The structure of the shipping industry is so bad that the owner is looking at his area and the manufacturer is looking at himself, the operator is looking at himself. So that gelling is not there. Very true, you said, sir.
Yes.
So, sir, a lot of work is going on autonomous ships. So, from your side, your point of view, what is the future development in autonomous ships?
Yeah. Now they have come out with mass grade 1, 2, 3, 4. So now they're really talking about number 2 and 3, where remotely operated ships will be running. And of course, we will be following the trials which is happening on shore with respect to automated cars and buses and trains, and seeing that it may come here. So fully automated ships taking decisions on their own, I think not another 30, 40, 50 years. Not in my lifetime, I think.
Something like satellite operation.
Very true. Remote controlled, yes, that could be possible.
Yeah.
Yeah,
We come to know within a decade time.
absolutely, absolutely.
Yeah. Thank you, Professor. Any other comments, queries, doubts from participants? Hari, are you fully satisfied? Please unmute. Hari, unmute your mic.
We have the next speaker who will satisfy him nicely.
Yeah, he's already boarded.
He's already voted.
Yeah.
Sir,
Welcome, sir.
as,
Rishikesh, sir. Yeah, Hari, go ahead.
sir, as a last question, that unmanned ship, actually, the E0 notation, that is, engine room will have a limited manning, and we have in the last vessel, we have done that E0 notation. And there are actually E0 notation means actually in the during the endurance trial, we will not be entering the engine room, so that engine room on itself, if any cooling is not sufficient, the standby pump will automatically, it will be started. If the pressure is low, it will be automatic, standby pump will automatically started, and it will come into operation, so that the manning is reduced in a such a way. And we have 16 or 17 alarms, E0 alarms, that only we can able to do. Like as you said, no sir, it takes a lot, decade or 2 decade time, maybe it will, we have need to acquire the many informations, like developments are
No, but this
underway.
unmanned engine room which you're talking about, this is 40, 50 years old technology, sir. Shivaswamy, sir. Japanese ships were
Yes, sir.
unmanned engine room has been there existing for a long time. And the Japanese people have experienced this. They have gone back. In fact, we had dual competency 15 years back. We had dual competency programs, deck engine combined together with this concept that there will be engine room, nobody.
UMS concept is very old. So autonomous is the new one. But operation part, UMS can be operated, but maintenance is very difficult. Go on autonomous vessel.
Sir,
Maintenance part is very, very
just
difficult.
1 minute. It is
Yeah, Mr.
it is
Krishnandu,
same
please.
like it is same like automated surgery, human surgery by automation.
Yeah.
Human surgery
Right, sir. Well, then,
by automation.
Thank you.
Same like this.
Right, sir. Thank you very much for this opportunity.
Thank you, Professor. We had a very good session, a lot of interaction during your session. Participants also very, very much satisfied. Especially most of the participants are doing research. Some of them already completed the research. So they cleared their doubts by interacting with you. Thank you very much, sir.
Thank you, sir.
Thank you. Thank you very much.
Thank you very much, sir. You
Thank
have
you.
provided an overall understanding of technology integration. You have described the opportunities and challenges in detail. You have also gone over the economics of technological change, technology drivers, design and operation issues, and potential solution. Your lecture provided numerous key takeaways. Thank you so much for your fantastic and fascinating presentation. Thank you, sir.
Thank you. Thank you, Dr. Lakshmi. Thank you so much.
Thank you, sir. Thank you.
Thank you. Thank you, participants. We can join again for the next session by 12 noon today. Use the same link. Thank you very much. Thank you all.
Thank you. Bye.
Thank you.
Thank you, sir. Thank you. Thank you, ma'am.
Thank you, sir. Rishikesh, sir. Welcome, sir. Welcome to our ASCT sponsored Atal Faculty Development Program. We'll start this session within 2-3 minutes, sir. Rishikesh, sir, I'm audible.
Mr. Shivaswamy, can you hear me?
Yeah, loud and clear.
Okay, that's great. I'm just going to turn on the PowerPoint so that I can.
Yes. Yeah, we'll start after a couple of minutes, sir.
Yeah, that's okay. But I'll just, I think.
Yeah, you make yourself ready, sir. Keep it on standby. Welcome, sir. Welcome to our Atal FDP program. This is day 2, session 2. Participants, you can mute your mic. Requested to mute your mic.
Just let me get this.
You can minimize
Yes,
the slide. You can minimize and keep it on standby.
Yeah, I have done that. Okay, I'll minimize it and keep it standby. I think all the participants can see me, and we're ready to go ahead.
Yeah, ready, sir. Yeah, we can start the session now.
Uh,
Madam, yes, sir.
yes.
Please wait, sir. So formal introduction will be there.
Okay. Just let me have a view of the participants. I think there are 25, that includes me. And I am told that the participants come from various backgrounds.
Yes.
Just a minute.
Yes. My heartfelt welcome to our beloved guest speaker. We are about to begin the session 5, which is on running effective shipyards in India. Let me take the privilege of introducing the guest speaker to the audience. Shri Rishikesh Narasimhan joined L&T Shipbuilding in August 2011 in order to start the production unit at Greenfield Shipyard, and it was his second time starting a team for shipbuilding. At L&T Shipyard, his team has so far built more than 23 ships and about 15 other floating crafts. His role of a startup manager to create a highly charged shipbuilding team required changing one's role from a layout engineer, team leader, chief motivator, decision maker, finally becoming a mentor to create other team leaders and empowering them to create a stable production line. His education qualifications include BE Marine Engineering from DMET, Directorate of Marine Engineering and Training, Calcutta, and an MBA from Milton Keynes, UK. He is also a certified first-class chief engineer and has sailed on bulk carriers, product and crude oil tankers for 8 years. Before his shipbuilding career that spans 16 years, he spent a decade as a surveyor with one of the world's leading classification societies, Det Naski Veritas. He has been the editor of Marine Engineer Review Journal and has spoken at many national and international seminars from time to time. With this brief introduction, I am handing over to Sri Rishikesh Narasimhan to start the session.
Dr. Thangalakshmi, thank you very much. Can you hear me clearly?
Yes, sir.
Okay. Give me just a second to uh, come out of my tech glitch. That is, I have to now show you the other screen. And
Yeah,
for that,
the screen is visible, sir. Screen is visible.
okay.
You go to your PPT, go to full screen mode, sir. Press F5. So that you good.
You are presenting. Okay, stop presenting is not the one. I have
Sir,
to go to full screen mode. Okay.
yeah.
Okay. Fine. Now, can you see everything? But
Yes,
I have
sir,
to open the screen up, right?
Yes, sir. Yes, sir. You just
So I
switch
have to go
Alt
to.
tab, or you have minimized the PPT, no, sir. You click on the PPT so that that PPT would be visible to you.
Okay. Just let me see. It's the first time I'm presenting this way,
Yes, sir.
so apply full screen, I think. Okay. But some more glitches.
Okay, sir. You just stop present it. Again, you present, represent. Stop presenting.
I'll stop sharing.
Yeah.
Then
Now
I'll
you
go
share.
back.
Yes, sir.
Full screen. No. Okay. Okay. Finally.
Yeah.
It's easier to run an efficient shipyard than to get on Google.
Yeah.
Good
Sir, go
afternoon,
to
everybody.
full screen mode, sir.
I'm in.
In the
F5,
top,
sir.
you press F5, or in the top you can
Single
see
slide
the
mode.
Do I have to press F1, right?
5.
F5.
F5. Is it okay?
No, it's not working. I hope there should be a function key. Otherwise, sir, you are seeing the presentation, no, sir, by yourself. You could able to see the presentation.
Yeah, I can see it.
Yes,
One
sir.
minute.
On the top, sir, in the top ribbon, you could see a presentation. Presentation icon visible, sir?
Presentation icon.
Yeah, top of home and insert, in between home and insert button on the top you have.
One minute. It says I'm already in full screen. So,
Could you navigate, sir? You just press down the next key. We will see
the
whether.
bottom one small icon is there, sir, for screen. At the bottom, near to that zoom, you can see one small icon is there. That you can
bottom
click
there's a
that.
small icon.
Yes, sir. At the
What kind of icon is it?
you can bring your cursor.
Okay, I'm going to stop it and then I'll go back. Just let me go back again. Present your entire screen and a window, it says. I'll go to window.
Share.
And then it says select the window. How to run efficient shipyard. I'll allow it. And then full screen. Can you see me now?
Yes, sir. Your screen is visible.
Screen is visible. And then you want to see me also?
Yes, sir.
Okay. That, I don't know how to do that.
So now you have that minimized PowerPoint presentation, which you could see on the bottom of your system.
Yes.
You click on that, sir.
Okay. Is it okay now?
Click on that. Now you press F5.
That
F5
is
or
F5.
F5. Yeah. F5 is a key available on the keyboard.
Okay, F function 5, right?
Yes, sir.
But
function key is F5.
It's not coming. Just let it be.
Yes,
can
sir.
you get? You can see me.
Yes, sir. Yes.
And you can see the screen, right?
Yes, sir.
Okay. Then I'm going to just go ahead.
Yes.
Now, can I just have a hello from somebody, because it's very difficult to speak to nobody.
Sir, while you are presenting, you could not you cannot see others, sir. You can see only your presentation.
Okay. Fine.
Yeah, you can start.
Is it okay now?
Same setup.
Yes, sir. It's okay. Yes, sir. You can start, sir.
Fine. Okay. Sorry for that. Actually, virtual presentations are good in some way, but if you know what is to be done. But first time it has a lot of own problems, and that's why live is always good. So my job is to present how to run an efficient shipyard. Now, there are many books which are written about. In fact, I'm talking about how to run an efficient Indian shipyard. Now, I had sent some questions, and a few questions before we start is, I was told that the audience is not exactly specialized in shipping and shipbuilding. So it's a very multi-focused audience, and therefore I have made my presentation a kind of, I will take it as it goes. So some interaction is required. So maybe, madam, you can interact when you feel that I'm talking too many specifics, or if I'm talking very generic and you need a question, please go ahead and stop it and ask me, because otherwise just one person speaking becomes a problem. Okay. Now, I had a few questions before we start, just to get the people thinking. What document defines India's maritime focus? What are the different kinds of merchant ships? What are the basic steps while building a ship? Which are the top shipbuilding countries in the world? Why should India aspire to become a major shipbuilder? These are the questions that I put forward because if you want to hear something that you have little experience about, I think that it's better to have some questions. But I do understand that there's one gentleman amongst you who comes from Cochin Shipyard. Can the gentleman say hello, or at least say hi to me? Because I'm going to direct a few questions to him.
Mr. Hari? Hari Parandam.
Okay. Yes. So Hari should say hello at some point of time. Now, let me start. You see, there are many books written about shipbuilding, but the process of shipbuilding is uh, talked about in terms of work breakdown structures. Just a minute, there is somebody. There are many books written about shipbuilding, and but there is no book that teaches you on how to define an efficient shipyard. I had searched Korea quite extensively, but I could never really get one. And uh, there are, also many management tools to allow shipyards to understand exactly how to identify the weaknesses by means of digital methods and even other management tools. But those tools can only be used when if you have the abilities and they can amplify your abilities. you know and one of the points that I'm going to talk about is how yards which are usually in less developed countries can come up and be developed. Okay, so shipbuilding defines a strategic space of heavy engineering, and there are many ships which you can see here, and amongst dead weights and complexity. Uh, Madam, do you have a fair idea of these kind of ships, or do you want me to define this slide more?
Sir, I have no much idea about that. And many participants are from various domains, so it would be better if you are explaining brief.
Okay. So I will very briefly explain that I'm going to talk mostly about merchant ships. And you can see that on the uh, x-axis, I have the size of the ship, and on the y-axis, I have the complexity of the ship. And there's a huge domain of ships, and ships actually they define the heavy engineering phase. Now, what has happened is in India in the last 70 or 75 years of our independence, we have been focusing first into agriculture. Then at the second level, we focused into you know government commodities, that is steel and coal and other large in the process industries. At the third sector, we started to go into uh, fast moving consumer goods, washing machines, and that was in the 70s and the 80s. There was a huge thrust into that area. Subsequently, we went into semi uh, finished or finished complex products, and the automobile was the end of those semi finished and finished reasonably complex products. Now, India is now venturing into uh, heavy engineering, which is possibly the most complex industries. And therefore, there's a lot of angst. And what you see in front of me, the screen in front of me, defines that strategic space. Now, India has tried to get into shipbuilding for many years. You can see that ever since 2005, we wanted to get into it and say that we want an 8% share of the new building. Subsequently, we had a maritime agenda in 2020, and we said that we should go with full force and get a 5% share of the world's market. But that again flopped. And now we have come out with a new maritime agenda 2030. The vision is to enhance the shipbuilding capabilities to position India as one of the top 10 shipbuilding countries in the world by 2030. And you can see the maturity of the reports have also increased over the time. Earlier, the reports used to be very visionary and, they wanted something, but they really did not know how to get it. This Maritime India vision that you see now is far more realistic, far more improved, far more focused, and it tells how to go about the entire way. Now, you can see the situation of India today. Even though we are one of the top 5 or 6 economies in the world is divided into two parts. One are ship owning and shipbuilding countries, which are primarily in Europe. Ship owning countries in Europe, ship owning and shipbuilding countries are in Korea, Japan, and China. China, of course.
So sorry for
India,
interrupting. Are you
yes,
moving the slide, sir, or still it is in the title slide?
the slide is moving.
But we could not see the slide, sir. We are still seeing the first slide. Sir, if you don't mind, could you give your phone number, sir? I can share my mail ID so that I can present from here, from my side. You can
Okay,
send
just
the
give
PPT
me
to.
1 minute.
Yes, sir.
Uh, my mail ID is
Yeah.
rishikesh22@gmail.com.
Sir, could you spell it?
HRISHI.
HRISHI.
HRISHIKESH
Ah,
22
22.
@gmail.com.
Okay, sir. I will send a mail from my side to which you
You see,
can
my
send.
current is also gone off here, There's a lot of problems from home, I must tell you. My
Okay.
wife is cooking. I'm not used to presenting from home.
Okay.
Uh, I really apologize.
Okay.
Uh,
Sir, have you sent the presentation to HOD?
no, it is huge. I have a lot of things to.
Yeah,
Just
it's
give me
like
10 minutes, 1 minute.
okay.
Can we have a time break for 5 minutes? I will
Yes, sir.
reorganize.
Yes, sir. Yes, sir. We can have 5 minutes break. Participants, you can stay here, just muting your audio and video.
Sorry, you see, I'm not. Actually, I can come down to the. In 2 minutes, I can come down to the IMU. It takes exactly 3 minutes. But
And yeah.
one
Sir,
minute,
if
can
you,
you see my
sir, if you,
presentation now?
Yes, sir. Presentation, one slide only we are seeing. Sir, please press down key so that we could check whether it is moving. Down
Yes.
keys, you press down arrow, sir.
Arrow.
Sir, how long will it take, sir, to come over here?
It take me exactly 5 minutes.
Yes, sir. Then you can come with that.
Yeah,
We have.
I think I'd better come.
Yes,
It
sir.
takes
You
me 5 minutes.
you have your pen drive, sir.
Yeah, I have
Yes,
my
sir.
laptop
Yes, sir.
and my
Yes,
pen
sir.
drive
Yes, sir. Yes, sir. You can come.
is faster.
Don't be in a hurry, sir. You come.
Yeah.
Participant, please be connected.
Sorry, madam, he is coming to headquarters or Uttandi premises?
No, here, sir. To our premises.
Okay, okay.
Participant, sorry from our side for the technical glitches. Sir has arrived. Please wait for another 2 minutes.
Dr. Tangalakshmi, can you see me and hear
Yes,
me?
sir. Yes, sir. Loud and clear.
Okay, excellent. Now I have to get this gentleman to allow me to give you the layout, right?
Yes.
Share the screen. No,
Yes.
sorry. இப்போ எப்படி ஷேர் பண்ணணும் இது விண்டோஸ்? I want to put my PPT. No, it is not open. I have to open it. Just open it. PPT. Okay. Okay.
Full screen, sir. Now open.
Okay. Full screen. Now
Open this.
open this.
Okay. Now present.
Present now.
A window. Window entire screen. Entire screen. Sorry.
Now what do I do?
Just click here.
No, it doesn't go back. That's the problem. Dismiss panna. Okay.
Entire screen.
Your entire screen.
Grant permission. Dismiss. Click here.
Yeah.
Share. Sir, good question. Hello.
Hello, Dr. Thangalakshmi, can you hear me
Yes,
now?
sir. Yes, sir. I
Okay.
can hear you, sir.
Now I have to ask them to present, and I will only
Yes, sir.
talk
Yeah, yeah, yeah.
like a
Yes, sir.
normal.
Yes, yes. Yes, sir.
How to run efficient shipyard. Hello. Hello, block panna. Can you hear me and can you see the screen?
Yes, sir. Screen is visible.
Okay.
Ask them to put in full screen mode, sir.
It is in full screen mode. Can you see everything?
No, sir. Sir, you just go to the next slide, sir. Let me check whether it
Can
is
you
moving.
see running an efficient Indian shipyard?
Yeah, first slide I'm seeing, sir.
No, the second one.
No, sir.
Second one.
No.
Okay. So why it is not coming is the question. Now what do we do?
Sir, you have a Gmail, no, sir? You can go through Google Slides, sir. You can present through Google Slide then.
Okay. I will.
Sir, otherwise, could you share this slide with me, sir? I won't send to anyone.
Yeah, I can share it, but then I don't have such a big.
No, sir. Sir, I will talk to that
See,
person. Like
nowadays
he
there
can.
is so many. 1 minute. I will. Copy panna. Nowadays there are so many restrictions on copying also.
Yeah, yes, sir.
No. Stop presenting. Stop sharing. Okay.
Mr. Hari Parandaman is available here.
Hari Parandaman?
Mr. Hari Parandaman, Kochi Shipyard.
Available, madam. Available.
Sir, our guest speaker wanted to interact with you. Sir,
Sure, madam.
Narasimhan, sir.
Yes, madam.
Sir, Hari Parandaman from Kochi Shipyard is available. You can pose some questions to him. You were at the beginning were about to ask some questions, sir. He is available now.
Just a minute. I am logging in now on the other one. Okay, I have a few questions. Just a minute. I have to put my new password. iPhone 8.
Message வந்துருவா சார்.
ஆமா.
Message சார். கால் பண்ணிட்டீங்களா சார்?
இது எப்போ என்ன பண்ணணும் இப்போ? எங்க மெயில்? Madam, as you can see, you can have the best software and IT, but unless competency is there, you have got a glitch. Yes. And I am now going to go ahead explaining that.
It's as difficult as running a shipyard in India, sir.
Yes, and now my people can now totally. Phone left. Yes, it's me. Okay, fantastic. Now you see the perils of importing foreign technology into your home. Copy artha? Okay, how much time do we have now left? I will cut my, do I have to cut my presentation short? Because almost 1.5 hours is gone.
Yes, sir. It's till 1:30. We have our next session starting by 2 o'clock.
Okay. So maybe, I have got.
Yes, sir. You can extend by 1:45 so that we can start the next session by 2:15.
No, I will cut it short.
Okay, sir.
I'll make it more interesting.
Yes, sir.
KIFG MWD. WD.
Sir, you are muted.
Hello, madam, can you hear me? Sound push. Madam, can you hear me now?
Yeah, sir. Now okay, sir.
Now is okay?
Yes, sir. It's
And
okay.
the presentation is also okay?
Yes, sir. It's okay.
So my presentation at IMU to run an efficient shipyard should be now called running an efficient Indian shipyard.
Yes.
So there we are. I am now going to start again, and I'm quite afraid to touch anything now, because in case something goes wrong. But gentlemen, please don't go away. Please stand here for the next 15 minutes. Then everything's all right. Okay. Now, I had sent a few questions, and those questions are: what document defines the Indian maritime focus? What are the different kinds of merchant ships? What are the basic steps when building a ship? These questions which I've got here are just some questions as a teaser, and since I am running short of time, I'm going to move a little faster. Okay. See, in short, India has been trying to get into the shipbuilding market for a long time. They thought they can do it very quickly, and they had a maritime agenda 2010-2020, which they thought that they can push things very fast, but again it fell flat. And now they have another maritime agenda 2030, which says we need to position ourselves as a top 10 shipbuilding countries in the world by 2030. Now, I could have gone a little bit detail into why we went into these things and we didn't do well, etc. But in short, it isn't easy. And why it isn't easy is what I'm going to talk about a little bit. See, there are two kinds of nations in the world. One are ship owning and shipbuilding countries, and one who don't do these activities. Now, India, being a very major economy, should have its own self-reliance, or at least part self-reliance, in carrying their own cargoes. You can see that the world is divided into two parts. You've got Europe, which were once upon a time shipbuilding countries, but now they are just purely ship-owning countries. And you've got the Japan, China, and Korea. China being the latest entrant, which has plugged in inside, and I think it has almost a 25 or 30% share of the shipbuilding in the world. And of course, ship owning also, China is on the top. India, unfortunately, is a major ship demolition country. But now we want to go from ship demolition into shipbuilding. Let's see. The Maritime Agenda 2020 actually this time has been extremely well written, and you must go into the website and have a look at the Maritime Agenda 2020 chapter 5 on shipbuilding, and it has put a lot of things which it never earlier understood before. And one of the things that is put here is that you can see here that it says that our you can see the screen here. You can see that even though we are a cheap country for labor, but still it says that our productivity is very low. Well, let me tell you, it is not as low as what they have written out here, but it's still low. Now, the point is that it's a paradox that shipbuilding is quite a complex activity, but somehow it gravitates into low-wage countries. Now, you will ask me, what is this present scenario in India? The state of the Indian yards today is like this. We've got a lot of PSUs which are active. You've got some small private yards which are active but mostly strained. L&T is only the only large private yard which is active. The rest of them all have collapsed in the last 10 years post Lehman Brothers. Now, on many times, when we talk about shipbuilding, we talk about having cluster creation. You can see that these are some of the ideas that people are given: creating an efficient capital market, creating a cluster, and making sure that your country has able to produce ships in a nice way, put technology into place. But actually, the main activity that really is a risk for shipyards is maintaining the order flow, the one which I've highlighted here. And now, to highlight that, I want to tell you why Indian shipyards don't do well. See, actually, there are two main risks while building ships. One is the technical risk, and the other is the market risk. Now, what happens is when you build a ship, you have to make sure that technically it is produced on schedule. It is also made up to standards. It can perform well, etc., etc. Somehow, by using of technology, by taking help from external help, you can manage the technical risks. But the other main risk that Indian shipyards have, which we are not able to contain, is understanding the market risk. And just to prove a point, let's say that you ordered a bulk carrier in, say, 2012. And let us see what is happening to the Baltic Index. In 2012, you have the Baltic Index, which is actually reasonably high. In fact, I haven't put the numbers here, but just to let you know that in 2011, the Baltic Index was at its lowest ever. It was something at I think it was 800 or something, which is 1000 itself with the benchmark, which is below the benchmark itself, and that happened because of the Lehman Brothers crisis. Then subsequently, the Baltic Index started to move up and up and up. And say in 2012 or 12 or 13, some ship owners in India got the courage to say that let's order a ship at this point of time. You ordered a bulk carrier. Now, the bulk carrier is technically, I would say, a moderate ship, less risk to make. And we say that two companies ordered it. Now, let's say what happens when the market goes and you deliver the ship, say in 2015 or 2016. There you are, the Baltic Index has fallen. It's exactly like what happens. You buy a share, you buy the ITC share, you think it's very good share. It was trading at 340. You went and bought it at 260, thinking it's a deal. And then, exactly 4 weeks later, you find out it's 150 and you're scratching your head. And this is one risk that we have all the time. Now, people say, forget the bulk carrier, let's not buy ITC share, let's go and buy something else different. And you decide to buy, some share in some petroleum, because finally, crude is always going to be required. So then you go and buy a share in the crude oil. You order a tanker in 2013, which is exactly what happened when the oil market was rising. You go and buy it. It happened to us in L&T. We got an order of 10 ships. Suddenly you find out when the ships are getting delivered, the market crashes. It goes down from 110, it goes down to 38 dollars a barrel. And so you have similar crises like this, and that is one of the major issues where we fall flat. Now you'll ask me, so you can see that our focus today is to understand that within these circumstances of a very fluid market, where market itself is not known to us, and also how where the efficiency and the risks, technical risks, are also not in our control, how shipyards can actually find themselves in a spot that they can continue. So we have got an answer amongst the Japanese, and the Japanese, what they have done is they have created a shipyard which is so efficient and their technical risks are so controlled that they somehow manage the market risk. Because if you have two risks together, it's very difficult, but if you can stem one of them, at least the other one can be controlled by means of your efficiency. Now, let's try to understand what happens. Current one.
No, you can.
Okay. I thought the same thing again. Can you hear me, madam?
Yes, sir. I could hear you.
Now, what is exactly the shipyard? So now I'm talking about how can a shipyard manage its technical risks. Forget the market risks. A shipyard is a factory that manages the flow of steel and converts it into a ship. So when you design a shipyard, the material flow path is extremely important. Now I'm going to show you a STX Genhe shipyard. Exactly what happens when you start a shipyard is your boss calls you and says, "Hey, get a design a yard." Now, what do you do when you've never seen an efficient shipyard? So you Google. You go and you see a shipyard like STX and you say that I'm going to manage it. Hello, Kunjo, please keep quiet. You have a shipyard like STX. Now here, by looking at the blocks here, you have no idea about how the shipyard is going to be managed. So you decide that my shipyard will have a throughput of say 2 lakh ton. It's going to make Aframax ships, and you have a dock size like this, etc., etc. You have some idea. You go into the shipyard, you move around and have a look at it, and then you see how the yard has to be arranged. You can see I will not get into the detail because I'll get into detail in the next couple subsequent slides, as I don't have much time. But all these slides, whatever I have taken, all these photographs are actually what I did when I was designing the yard. I went to several other yards and I checked out whether their yards can be copied by us. So this is a photograph taken by me with a camera in the XTX to see the skid launching system. Now I have a question to the one person that when you go and start to design a yard, I think there's one gentleman from Cochin Shipyard, and I want to ask you, if you have to design a shop and you have to find out what is going to be the height of your EOC crane, overhead crane, how do you decide the height of the crane? Can you give me an answer?
Sir?
Yes, I think.
Sir, am I audible, sir?
Yes, you are audible.
Sir, yes, warm welcome, sir. Sir, I am Hari Pranavan, working as a manager inspection and quality in Cochin Shipyard Limited. And sir, as per the question, actually we have two gantry cranes, which we can is assisted by other movable cranes. So the block which is fabricated in the assembly shop can be transported easily in the dock, and the height is actually enormously high. Exactly, I cannot give the figure, but we followed actually Mitsubishi Heavy Industries style design only. We have taken during the construction stage. The shipyard has copied the MHI design.
Okay, so I will. This question was just asked to let you know that is there any book that shows you how to design an efficient yard? No, it does not. And if you have to design the height of this OHC, that is overhead crane in a shop, all you have to do is you find out what is the largest block that you are going to have make in that shop. You measure the diagonal D, you give an allowance for the wire slings, add the ground clearances, and voila, you have the height of the OHC crane. Correct?
Yes, sir.
Answer is very simple, but if you don't know the answer, you will be asking MHI. Okay. Now, I want to just show you a quick movie here that this is what we do when we design a shop. Okay. We have to turn this. This is a high-speed movie I have made here. I'll again show it again. When okay, this is the block that we are turning. It's captured in our shop. The height of the OHC crane is exactly made in such a way that it can. Okay. So now my question now is that yes, how do we design a yard with an improved process? Now, when you are designing a yard, there are 2 points of the yard. First is that you design the layout of the yard, and secondly, you design the processes of the yard inside each shop. So I am not giving any yard that, because of confidentiality, I cannot put a yard in totality and slides. But I have actually made a hybrid of many of the yards to just indicative and show you what it is. It is not any specific yard. So please forgive me for that. But if anybody wants to know specifically, you can call me up and I can tell you. So now this is the yard that I had worked with Comac and IHI, both of them, to make it in Cuddalore. And the first job is that we have to find out what is the capacity of the yard. You can see the framework here. The environmental criteria, the market criteria, and the product mix, I'm taking it out of here. Technically speaking, as soon as this is known to us, the market is known to us, the shipbuilding capacity, the launching system, the manpower leveling, block size, dry dock outfitting key, working time, all these items together, they decide the yard layout. What we do is uh, we use these basic criteria, we make a framework over the area that we've got, and then we put it into a matrix which says how the yard will be. Uh, we put it into a relationship matrix which allows you to check the workflow and the processes. For example, I will go back to it. What happens is, first we have to make the breakwater, for which we check out the wave patterns over the year, for the whole year of the wave which is coming, so that the breakwater can be designed. We have to go specially to specialists. There's one in Pune who is pretty good. I've forgotten the name, but the full form I've forgotten. But I've gone there. They've got models of every yard every breakwater in India, pretty elaborate, and they're very good at that. They'll tell you how exactly a breakwater should be made. Subsequently, you check the bathymetry and surface elevation, and then you decide. The yard layout is managed by means of relationship diagrams. When I talk about relationship diagrams, I am talking that which shop should be placed in which area so that the material flow will be unhindered and smooth. So you create a relationship diagram by means of this matrix. You talk about the steel stockyard. U means, it should be close to, it is essential, important, ordinary, or I think there's here, or unimportant. Unimportant means, is the steel stockyard required to be next to the outfitting center? Well, it's not important. But if you talk about the pipe shop, is the pipe shop necessary for the pipe shop to be next to the paint shop? It's important, but not essential. But wherever E is written, it is essential. So we create these kind of matrices and check the entire layout of the shipyard. Subsequently, what we do is we check the launching method, which is the most economical launching method you have. In Cochin, I think they have a dry dock. Some people prefer to have land level launching like STX. Some want to have a floating dock, etc. And at this point, the layout of the yard is decided. This is the layout of the yard that we have got in Larsen Tibro, and we have used these kind of matrices for the yard layout. Now, the next step is, how do we put the processes in the shop? Now, anybody who goes, they will go and ask a German, or they will ask IHI, and then they will find out IHI has got very good processes. So this is one process that we have in STX, or one of the Korean yards, I think Daewoo or Samsung or something like that. You cannot put that same process, because you can see that the same construction in India is like this. And the same production shops which have got very clear schedules, and you can see how neat and clean it is in Japan. The same thing in one of our shipyards, I will not name it, it is like this. So there is a cultural issue, and if we want to just transport something from a foreign yard and put it into an Indian yard, it's going to be troublesome. As I was, and a prime example is myself. When I was told that your wife will be cooking in the kitchen, your mother will be playing Carnatic music, but you have to present the shipyard. Obviously, you cannot do it from your home. You have to come to IMU and get your act together. Okay, so these are also some Indian yards. So now The next point is, once you have the layout of the yard in place and you have got the shops in place, you have to do what is called production engineering. The sophisticated Japanese and Korean yards have many subtle processes that are inside the shops, which must then also be decided. And here is the paradox. How can you plan a task that you have never seen or done before, and how can you capture it and put? That means what I'm asking is, how can India have a modern shipyard when none of the Indians have seen a modern shipyard? Is there anybody who dares to just give some suggestions? And my next slides are on exactly how to do that. But if somebody is volunteering to give an answer, I'll be happy.
Sir, actually, in our sir, I am Hari. Sir,
Yeah.
the actually integrated hull outfit building. The process only we are actually we are try to follow in some vessels, but in other vessels it will not be feasible enough. Integrated hull outfitting building.
Yes. So I'm coming to the next part now. Now, what happens is in India, they talk, all the people, they are giving this integrated hull. This is a catchword that they use in most yards, without realizing that the work breakdown structure, etc., addresses only one part of the flow of production engineering. And to really capture the efficient yards have to capture the entire flow from end to end. I'm going to just throw some light on this before we get into a discussion session. Okay, I can see that I'm at 1:12, so I have to somehow manage to complete this within the next 10-15 minutes. Okay, now what happens is, if you can see this slide, you are how you build. If you see Indian yards, are the blue line and foreign yards is the black line. Now, it is a little bit complicated, graph for those people who are not initiated into shipbuilding. So I've made it a little simple and shown you in this one. See, you just see this black and you see this blue line. This is the black line and you see the blue line. What happens is that when the ship is launched, this is at this point of time, your outfitting in Indian yards is about 30%. But when the ship is launched in a Japanese or a Korean yard, the outfitting is nearly 80%. And this defines, and this is what Hari talked about in Cochin Shipyard, they're using integrated activities. Now, if Indian yards have to succeed, I'm not talking about my yard or somebody else's yard. If Indian yards have to succeed, then there has to be a body that captures this knowledge and systematically disseminates it to every other shipyard in India. And that is how the whole nation can grow. You cannot grow in islands. So let me go to the next slide. What you do is, now when you decide the detailed production facilities of the yard, you go through a very complex methodology where input data of the work breakdown, the workflow, the capacity requirement, and the equipment selections are all carried out. I will not get into, but in short, what you do is every production area, you decide what is going to happen and exactly what are you going to do. So I'm coming to, supposing you have got a, your product mix decides that you're going to be building such kind of ships. You're going to build a Cape-size oil tanker. Then the first thing you decide is, in my Cape-size oil tanker, how much of panel line, that is how much of parallel body of blocks do I have to make? How much of curved blocks do I have to make? And how much of deck house and how much of other miscellaneous items of steel I have to process? For those who are not familiar with shipbuilding, I will just explain that the steel that you make in the ship has got a shape. So when you make blocks which are parallel, they require a different treatment than blocks which have got curves. Similarly, you have got deck houses which very thin steel have got different treatment than others like hatch covers, etc. So you see the treatment of the steel in various areas, and based on that you create production shops and you go very much into detail that what is going to happen in each and every area of my shop. uh, unless there is a question, I will skip these slides. So what you do in short is you calculate the material flow and how the material flows into each and every shop, and that is how the size of the shops and the equipment in the shop is decided. Now we have done this for a preliminary one. I just simplified that other one. That if your steel plate and profile is say 27,000 tons the whole year, you see how much your plates you have to cut. Your cutting machines will be decided by that. How much of profiles you have to cut, that means profile means small plates. How much of outfitting you have to do, how much of fabrication you have to do, and you decide this. I'm not getting into details, but you can get the general idea. And then you sit and decide that to get the output. If you remember on the first slide, the government of India had said that India takes around 150 man hours to make 1 ton of steel, which the Koreans do in 50 man hours or some 30 man hours. I will go back to the slide just to I can go back to the slide, but I'm afraid, because you touch anything in this machine and I will not know how to go back to the normal situation. But you can generally, at the end of the presentation, I'll go back to the first slide and show you that one of the main reasons why we are not competitive is because, the shipbuilding is not exactly like, shipbuilding is actually like what can I say, like a A.R. Rahman making music. If I just get you the most fantastic equipments and get you, Yamaha synthesizers and Bose speakers, it doesn't mean that you can make Ilyaraja kind of music or A.R. Rahman music. You have to have tremendous amount of competency also to know exactly what you should use. So when people say that automate everything or just put something which is the most modern technology, it doesn't mean that you can do anything much with it. We'll come to that in the end when I'm discussing about manpower in efficient shipyards. Okay, so this is something that we did in our own shipyard. We checked out what should be our tonnage, and then you can see that I did a lot of brainstorming. These are all my own sketches which I made of what kind of jigs to be used, what kind of fixtures to be used. So we do it all the time, and this is just an example of a panel and block assembly that you have. Many modern shipyards in Europe have it. They often tell you to buy one, and it costs millions of dollars, something like 2 to 3 or 4 million, something like $6 million about 10 years ago. It probably will be $8 to $10 million. When you buy it, it will be like another, piano in your house. It will be looking very nice, but nobody will be using it. So what I'm trying to say is that to make an efficient shipyard does not always mean that it is hardware. There's a lot of software involved in it, or brainware. Now, one of the brainware that I'm talking about is how to make a three-dimensional block. Now, when you make a three-dimensional block, we go a lot into the details or in depth of how this block has to be made. I'll get more into this in the next slides. And this is how we keep the time. We see that you can see here that we see the block sizes, the calculation of the floor area, how many days the skid has to be there. That means if this block will be remaining in that place for how many days, how much days it takes for a man to complete sub-assembly, block assembly, how many days of inspection it takes place. Okay, those who have gone to a shipyard can relate with all this. And then you make it in such a way that this schedules are adhered to. And this brings down the risk of how much time it takes to build a ship. So the productivity calculations or fabrications are calculated and then implemented by following up daily. Okay, so this is a material flow plan in a yard. That is the contractors who are there. We have to tell them exactly how the material flows. This is one of the shops that we got in the Katabili shipyard, and this is what we had earlier done before, how the material flow will be calculated. And these, you can see that material comes from here, gets into sub-assemblies, blocks are made and blocks come out. Okay. Now, one of the things we also do is how once you have got your your methodology of how you can produce a ship in your yard, you check out how to monitor the project through ERP. And I have told this thousands of times to people, because I am very down. I mean, most of us who are in the business realize that new methods of computer-based monitoring methods are very good to monitor, but data collection is as good as the data you collect, garbage in, garbage out. So before you make ERPs which are with software, most of the Japanese, they still use Excel sheets, but they do a job extremely well. So I would say that while big data collection, using data analysis, using digitization is all very good, but still competency is the most important in yards, and that is how the Japanese have still managed to remain competitive all these years, by upgrading their basic understanding. Okay, so for those okay, so to make a long story short, when you go to a yard and you see a yard layout in this fashion, you can see that a lot of intelligence has gone into this complete layout, which is what we have done in our shop. This is not our shop. I think this is a one of the Chinese shipbuilding yards, which I had gone there in 2012 or 13, and I took a photograph of this. Now, we have talked about just making steel, but you also have so many other jobs to be done. And this is what we did. This is some brainstorming that I did when I went to Japan, of how our pipe shop should be. And based on that, we made a lot of calculations, came back, and we changed our pipe shops and made the flow better. And we are able to improve the pipe shop now. Our target was around 5,000 spools a day, and we are able to do almost 3,500 spools. 5,000 spools a month. We are able to do around 3,500 spools per month nowadays. I won't get into this, but now what I'm trying to say is that finally, when you have a shipyard, most shipyards, they invest in such a way between technology and human capital, so their yard is most competitive at a certain point, at a certain size, at a certain throughput, and a certain ship. They cannot build, or you cannot have a shipyard that can build all kinds of ships. You specialize in some sizes, and that is how it makes your yard most competent, and efficient. Okay, I think we've been on for quite a while, but to make life a little bit interesting, I'm going to just quickly tell you how a ship is built. So this is a small delivery, 2002, a delivery from CSL, and 2010, this is a delivery from HSL, and this is another delivery from CSL. Those who are from CSL can take some pride. They build very good ships. This is a ship that we built in Katapalli. The process is simple. We take a ship, we shape it, make the hull, and subsequently you start putting the machinery inside the hull, and the blocks are made in the floor. We give instructions of how the blocks have to be made, and this is a detailed block assembly procedure. You can see that you are planned like this. You make a block division plan, you make an erection schedule, then you make a it goes from the bottom. You make a cutting schedule, you make a block schedule, you design issuance of each drawing, you make an erection schedule, and you make a block division plan, and then you make an erection schedule, and that's how the ship comes out. And this is a loading schedule of how each shop will be loaded and how many people we've got on that block. Suddenly you'll find out that in Durga Puja time nobody will be there. Everybody will run away to Calcutta. So you have to ensure that that's not the time when you're delivering most of your ships. Then you will be in trouble. So you make sure that when everybody comes back in the winter time, where productivity is very high in India, you ensure that your plans are made in such a way. So this is another hull shop. We are installing pipelines here. Then we fit the machinery, complete the hull, move it out. Then finally, we float the ship. Many yards have got many ways to float it. We have got what is called a ship lift. We take the whole ship, put into a ship lift, and we put the ship into the water directly. It's a very large ship lift. It can take up to 18,000 tons, which is practically a ship of more than 180 meters long. 185 to 186 meters long ship we can take, which is practically good enough for our yard. Our yard can make medium-sized ships. This is one of the ships that we have built, and I'm going to show you some other ships that our yard has built. This is a view of the yard from a 2019 calendar. Unfortunately, I'm not able to show you absolutely live photographs of the yard because of so many confidentiality requirements. But this is a typical yard. This is a Cartability yard that we've got. This is one of the ships that we built, and this is a sea trial that I took for one of the ships. And I'm going to show you a nice picture of one of the ships that we built. That is, this helicopter came, and with this helicopter, this ship was built. This actually, I was inside this ship, doing the sea trial when they took this picture. It's got a very nice speed, I think 26, 27 knots. And we've also built, large floating docks. In fact, Andaman has got one of the floating docks made by our yard. I was also the project head for this one. And this is a photograph of that one. The first floating dock that they have in Andaman is made by IHI, and the second one made by Larsen & Toubro. It's quite a, I would say, landmark achievement for the yard. Those of you who are naval architects will see that floating docks are a little difficult to manage. Okay, so the key takeaway that I have got are a few points. Efficient shipyards require to have smooth flow of materials. The way they work is the man will move, the machine will stay in the same place. Sometimes in inefficient shipyards, you will have one welding machine which will be used by 3 people, and every time it has to move. That is not the way. You have to have the man to move, and you have 3 machines instead. The yard capacity should be known, and each station must serve a specific purpose. Outfitting is maximized at the block stage. This is just one of the aspects which Indian yards are trying. Most of the foreign yards do not tolerate revision. They ask for rework, and they are very complicated, and they standardize ship designs. If anybody has any questions, I can get into more detail, but as of now, I'm going to just make one key takeaway, that for an efficient shipyard, the focus is on that the shipyard should have one efficient operating point, that is so many ships of certain size to be done per year. It cannot handle all kinds of ships with efficiency. Yards are designed to operate at a certain efficiency only. This efficiency is scientifically embedded into the process flow. And one of the key takeaways is, since most of you are academicians, that a body like IMU must capture this from yards like us and put it in one place, because otherwise, as we retire, all this knowledge gets lost. Okay, so I will skip this slide. Okay, now how do we manage the people to run a yard? I will go very quickly into this and take only 10 minutes. Madam, do I have 10 minutes?
Yes, sir.
Okay. Now, efficiency in production is actually equipment capacity into productivity. If your productivity is X, you multiply it by the equipment capacity and you see the production of the yard. Now, most of the yards, the humans become the competitive strategy to build in that yard. It's a barrier, a strategic barrier for the yard. I cannot take 3 people from my yard, put them into some other inefficient yard, and ask the yard to go, because it's like an orchestra. You cannot have a full orchestra that plays in with efficiency if you just take one drummer and one flutist. It doesn't work like that. And process technology is a unique set of activities that determine the stage-wise production of the ship in a given shipyard. Now, process technology and human wear, they have to be trained for the yard to become efficient. Now, what happens in our yard is most of us have migrant labor, and one of the challenges is that the migrant labor have to be trained. Now, this is where HR can play a role, because ship repair yards work on different strategic dependencies as opposed to shipyards. In shipyards, the two key internal tasks to manage the risk in the yard is to get a process technology, or what should I say, the way your ship is produces equipment to a certain quality and time, and managing the people. These are the two things that is completely in the control of the yard. The other things are not in the control of the yard. Order book. What has happened when China collapses? Yesterday there was a news, Evergrande, there's a company with $300 billion of something money which they owe, and they're going bankrupt. You have no control over what happens in Afghanistan or in Iraq, or somebody blocks the Suez Canal. But these internal things is full control of the yard. I won't go into this. I had already discussed this before. But standardizing the skills is the key area in human resource. And we have a terrible time, because most of the labor that comes to our yard today, shipbuilding is hitherto still an unorganized sector. You have people who come from Bombay, you have people who come from UP and Bengal, and they work for a certain time. By the time their skill sets are put into place, they go back, and they come back after Chhat Puja. It's another new team that comes. The old team is gone away. So this is a big challenge that we've got. So what we are doing is we are defining the process, that is a build strategy, and without a defined build strategy, the organization that is evolved is an administrative organization, but not an organization that can produce. What I mean to say is that on many occasions, you may have a shipyard that is very neat and clean, and you may have a shipyard that is very well organized. You follow safety rules, you follow all the audit guidelines, but an administrative organization doesn't necessarily be able to produce good ships. What I mean to say is, you may have a fantastic hospital. There are several hospitals that are so good. You have good, reception, neat and clean toilets and corridors. But if there is no doctor to do surgery, that hospital is not going to be a great hospital for a long time. So what we are doing is, we are defining a process and we are training the people. Now, most of the training which is imparted to in India in terms of welding are basic skills. But basic skills have to be dovetailed to a process, and only then the skills are amplified. And in India, often there are no defined build strategies. I'll quickly ask. So what happens now is, in a very good administrative organization, you have got an organization with different departments, and they work in silos. But actually, when a ship is being built, you can see that as a ship progresses, these different departments, they interact very closely and seamlessly, which means that if you create very rigid systems which are hierarchical, it does not work. So what we have done is, I have taken the hierarchy and I have tweaked it. If I'm the head of production, the entire hierarchy is made circular. I have a project manager that controls each ship. I have got these red points are the heads of the department. The heads of the department actually take only critical calls. The day-to-day calls are taken by the boys who interact as teams with the project manager taking control of each ship. Of course, it's like a federal state in India that you have a prime minister at the head who has got ministers, and each minister then works with the states. It doesn't work so smoothly, but Just like it works in India with a democracy, with some amount of hierarchy and legal rules and regulations, shipyards also have to work like this. This is also another science of how you organize yourself to work in a seamless way. So this is one key takeaway on managing human resource. The second key takeaway is that skill and competency is not the same. Skill is not the same as competency. For example, you may know how to sew, and you may know how to cut, but a tailor is somebody who can actually manipulate the measurements with whom he sees and cut it to give a fit to the person. The same height and weight of two people, if one person is fat and one person is thin, a master tailor will know exactly how to tailor his cutting to suit the person's body. So this is very important. And I'll show you a slide on what we do for that. Okay. Before I come, I'm going to take a risk and come out of this because I wanted to show something. Stop sharing the panorama. Okay, I will show that in the end because I don't want to, take a risk. But in short, madam, can you see my slide?
Yes, sir. Visible, sir.
Okay. So the topic which was given to me was, how can you manage an efficient shipyard in India? Normally, people always talk about how the design can be made well, or how the work breakdown structure can be done well, or how you can manage many other methods. But I say that if you want an efficient shipyard, you have to optimize a yard layout for efficient material flow. You have to define your work processes. You have to make the people so competent that even if the drawings are not perfect, they understand what is to be done. And this way, you can reduce the risk of quality, cost, and time. So if yards have to sustain over many, many years, there are two risks that they face. One is the market risk and one is the technical risk. If we do it in a systematic way by means of academia and the yards like us, we can at least minimize the technical risk. The market risk is another thing to be discussed in another time. And before I go, I'd like to make life a little bit interesting. I've got one video which I want to show. And in this video, I would want you to answer this one question. What is the speed of this craft? This is a craft that I went for sea trial, and I took this picture right from the bottom to the top. And just to make life a little interesting, So can you tell me what speed is this craft at?
Around 35 knots.
Perfect. Okay. Can we go back to the one? Okay. Thank you, sir, and sorry for all the glitches, but that's how Indian shipyards work.
It's a practical difficulty, sir. Same like running shipyard.
No, I don't do much work at home. I'm an old man and I have got old people at home. So
What was the actual speed of that particular craft?
this is 37 to
37.
35 knots. Actually, this speed is we reached 42 knots.
Okay, max. Audience, any doubt, questions? Hari, Mr. Hari is ready.
Sir.
Yeah, please.
Sir, actually, sir, it is the shipbuilding is the integrated process, which it's sir clearly pointed out that it is a very complex process, sir, because the production flow, the material flow, and the construction is in line only. We can in time we can finish the ship in the for delivery. Otherwise, we will be slipping the schedule. Like we experienced in our shipyard also, sir. Like sir said, told that Korea 80 percentage they will complete before the launching, and the 20% work will be pending for the after the unlocking. That means after launching, 20% of the work will be pending outfitting works for before delivery. Like in we are also following, and here the thing is actually it takes very critical because rework and many corrections, many changes which used to come, which will be foreseen, which cannot be foreseen at the time of design. And so there only I actually myself from a quality control department, we have very less comments or corrections, but the design will take a pain to foresee many cases, many points in advance, and they are doing their best in their control. And however, in that way, we are succeeding in the yard, sir. And now for the last 3 weeks, we have completed IAC trials completed, indigenous aircraft carrier. And one passenger we have delivered for Andaman Nicobar, we completed, sir. And very recently that DRDO and research vessel we have completed, which took very long time on electrical propulsion vessel.
True, but
I cannot deny that.
Sorry to interrupt you, but actually, at a basic level, integrated shipbuilding, etc., is acceptable. But when you are going at a level in which the country, India, wants to put itself as a 10 large shipbuilding nation in the world, we have to look at how to minimize our risk. So the two major risks is no Indian ship owner can order a ship in India if he has not mastered the market risk. And I had actually asked a Norwegian Minister of Commerce that, sir, can you please teach me how can you predict what ship is required 2 years from today? He said, that is my trade secret. I will just give you a parallel. The issue is not on how to buy a share, how to go, many people don't know how to buy a share in the software. They will teach you, oh, you go to this site, then you click this, you register yourself. That is the process of buying a share. But how do you not lose money in the share market? This is what I want to tell. We have we are now crossed that stage of how to build a ship, how to make it efficient, how to make the welder build a ship. All those are not anymore, I'm not bothered about. How can I buy a share of ITC at 150 and see that I make 100% profit, and not be normally I buy it at 300 and lose 100% loss? That is how I should not. That is why India is losing. India is not losing because we don't know how to build a ship in India. Those days are all gone. We don't know how to control the market, which is manipulated and completely in the grips of the Koreans, the Greeks, the Malaysians. They had this is the secret, and on many occasions, I have come and I have told IMU that naval architecture and getting into what you call finite element analysis, this is not anymore our forte. We have to concentrate on this, and that is how we have to get into this business. I mean, if I can just put this seed of thought into the audience, I think I have done my job for the last 1 hour.
Any more questions?
Any questions?
Any questions from the audience?
Yeah, we can conclude.
Sir.
Thank you, sir. Thank you very much for your kind presentation. Very interesting and informative. So I hope all the participants were understood what is the shipyard operations. Those who are from non-marine sector. Thank you. Thank you very much.
Thank you very much, sir, for your outstanding presentation. We all had a general idea of what shipbuilding actually entails. We realized the true challenges of running an Indian shipyard after listening to your presentation. It's as difficult as a person with a strong desire to become a film hero faces numerous challenges. Thank you for your time and effort in imparting real knowledge on the topic running effective shipyards in India. Thank you very much, sir.
Thank you, Dr. Tangalakshmi.
Thank you.
It is nice of you to say that. Thanks.
Thank you, sir. Friends, we can rejoin at 2:15 for the next session. Thank you.
Thank you.
Good afternoon, sir. Please unmute, sir. Your mic is muted.
Good afternoon, sir.
Good afternoon, sir. Second
sir.
session got delayed nearly about 10-15 minutes due to some technical glitch.
No. Okay, no issues, sir.
Yeah, we'll start, sir. We'll wait for a couple of minutes.
Okay, sir.
What about the regular classes, sir? Already started?
Yes, sir.
Regular classes being started, going on?
Going on, sir. Some are doing practicals, and for some we have started the theory.
Theory classes. Rest all are
Yes,
through
sir.
online mode.
Through online modes.
Okay, sir. So we have some pending practical classes followed by examinations.
Yes, sir. That is why we have called them to campus. So they are doing the practicals. For some, the theory is going on in online mode.
Okay, sir. Yeah, good afternoon, audience. I hope all of you finished your lunch. So we can start the session, afternoon session.
Shall we start, sir?
Yes, sir. Yes, sir. Just a moment.
Okay.
Good afternoon, everyone. We are for the next session on alternate fuels. Before into the topic, I wish to introduce our guest speaker for this session, Shri S. Parandaman. He is presently working as a teaching faculty in HMT College, Chennai. He has served as chief engineer for a period of 10 years in Varun Shipping Company, Mumbai, mostly in oil tankers. Except for 2 years as chief engineer experience in anchor handling and towing ships DP2 class, the entire sea career was in oil tankers. Subject he is handling presently is on boilers, steam turbines, gas turbine, marine heat engines and air conditioning systems, marine auxiliaries, fire etc. He is a passionate teacher. His entire career while sailing was with Varun Shipping Company. Without further ado, I am handing over to our guest speaker, Shri Parandaman. Please, sir.
Thanks, Doctor, for the introduction. Now, good afternoon to all the dignitaries present. My presentation is on alternative fuels. Before I get into the presentation, I would like to say a few things. since this is on virtual mode, I have made backups for the internet connectivity as well as for uninterrupted electrical supply. Despite the backups, if there is a technical snag and my connectivity is lost in between, kindly bear with me, be patient. I will be joining in a short period. I know it's very difficult to focus after a lunch, but the topic is very interesting and I will try to present in a manner that that will keep all of you, keeping your interest on. During the ongoing presentation, you can raise questions in the chat option. I will try to answer your questions. 45 minutes later, we will have around 5 to 10 minutes break after 3 o'clock. During that session, I will take up your question and then we will proceed for another 45 minutes. That is is it okay, sir?
Very much. So you can
Yes, sir.
continue.
Yes, sir.
Yes, sir. Well copied.
Okay. Thanks. In this session, we are going to see what a fuel is, what technical requirements are to be fulfilled, what statutory requirements are to be fulfilled by the fuel, what are the conventional fuels in use at present, and why are we looking for alternative fuels, and what are the alternative fuels available, their characteristics, benefits, and challenges in adapting them to the marine environment. So we are going to see that one. So I will share my presentation. There is a sharing option given.
Sir, sharing option.
You find an arrow mark at bottom.
No, I have done that one. And now it says not responding. That is why.
Yes, sir. Sir, we have not restricted anything. All controls we have made open.
Okay.
I think some network issue.
Sir, he has left the meeting. I hope he will be rejoining. While rejoining, he could able to present.
Yes.
Sir, should we make a call to him? Sir, you are muted.
Yeah, I conveyed, ma'am.
Yes, sir.
He'll be joining shortly. Yes, sir.
Yes, sir.
Yeah, you can start.
Okay, sir. So now the screen is visible?
Yeah, very much, sir.
Okay. Thanks, sir. So what is a fuel? It is one of the energy sources, a combustible substance consisting of carbon and hydrogen. When it is combusted, it releases the energy. So these we have got power generating machineries that use fuel. They are IC engines, steam turbines, gas turbines, and fuel cells. Out of these four power generating machineries, the combustion takes place in IC engines, steam turbines, and gas turbines. But the electricity is produced in fuel cell by a electrochemical process. So that is the difference. But everywhere the fuel is required. So a good fuel is expected to have a high calorific value, low moisture content, moderate ignition temperature, low content of non-combustible matter in the form of ash or clinker. The combustion should be controllable, should be of low cost, should have moderate velocity of combustion, should not give offensive odor, but very importantly, it has to fulfill the international, national, and local environmental regulations aimed at reducing pollution and making ship sustainable. So ISO 8217 specifies the various parameters required for fuels that is to be used in marine diesel engines and boilers. The kinematic viscosity, cold flow properties, catalyst fines, the density, the cetane index, which determines the knocking characteristic, the flash point, oxidation stability, sulfur content, water, ash, hydrogen sulfide, acid number, carbon residue, etc. Similarly, are used in marine gas turbines. ISO 4261 specifies the various requirements. So if you look at the sulfur content specified in ISO, it will be more. They are technical requirements. But the statutory requirements are different. So the fuel purchaser, when he orders a fuel, he has to specify what has to be the sulfur content he wants. So the fuels at present in use, the major fuels in use at present in the marine industry, MGO, HFO and MDO. MGO is a marine gas oil, it's a distillate. ISO 8217 specifies 7 categories of distillate fuels which are to be used in diesel engines and boilers. And out of these 7 categories, one is meant for diesel engines, which are used for emergency purposes. And that is where the flash point of this fuel, which is used, that is brought to 43 degrees centigrade for emergency purposes, minimum. But otherwise, other fuels, which are used for main engine, boiler, they are minimum 60 degrees centigrade flash point it should have. And the HFO is a heavy fuel oil. It's a distillate, sorry, it is a residual fuel oil. And 8217 ISO specifies 6 categories of residual fuels. MDO, marine diesel oil, is a blend of distillate with small proportion of residual fuel oil. So what has made us to look for alternative fuel? These fuels we have been using for so many years. We are familiarized with their handling, usage, etc. But what made us look for alternative fuel? It is mainly because of the international, national and local regulations aimed at reducing pollution. So who are the bodies making these regulations? Globally, it is IMO, International Maritime Organization. And locally, the European Union, United States Environmental Protection Agency, the California Air Resources Board, Norwegian Maritime Authority, and others, they are making regulations for the ships which are entering into their areas. So, which gases are aimed at for reducing pollution? One is sulfur oxides, the other one is nitrogen oxides, third one is carbon dioxide, and the fourth one is total greenhouse gases. Why we split carbon dioxide, total greenhouse gases and all, it is because of the target set by IMO that we will see later. So this MARPOL Annex 6 Regulation 13, it is limiting the NOx emissions from diesel engines, marine diesel engines, which are over 130 kilowatt. So the exception from this regulation is engines serving emergency purposes such as emergency generator engines, emergency fire pump engines and lifeboat engines. So otherwise, this is applicable to all the engines. And this regulation specifies 3 tiers, tier 1, tier 2 and tier 3. So tier 1, the limits, they are all applicable depending upon the speed. They are all applicable for the engines which are fitted in vessels after January 2000, and tier 2, which is more stringent, the NOx limitations, that is applicable for engines which are fitted in vessels 2011, and tier 3 is for emission control areas. If the vessel has to go to emission control areas, it's still more the limitations are set. Apart from MARPOL regulations, the additional measures to limit NOx are introduced by US Environmental Protection Agency, California Air Resource Board, and Norwegian Maritime Authority. Their restrictions are still more than the IMO regulations. And coming to SOx limitations, MARPOL Annex 6 Regulation 14 limits marine fuel sulfur content to 0.5% or less globally, and it limits it to 0.1% maximum in an emission control area. So this 0.1% in emission control area, that has been there since 2015 January, and this 0.5% is there since 2020 January. So having met the emission criteria for SOx and NOx as set by MARPOL Annex 6 regulations with the conventional fuels, now the biggest challenge for the industry is to meet the targets set by IMO on CO2 emissions per transport work and total annual greenhouse gas emissions. When we say per transport work, that is how much CO2 emitted per ton of cargo transported per mile. That is how they calculate. Now, this IMO Marine Environmental Protection Committee adopted resolution in April 2018. They target to decline the carbon intensity of international shipping, and they want to reduce CO2 emissions per transport work by at least 40% by 2030 and reduce by at least 70% by 2050 compared to what the level was in 2008. So that is the target. And another target is to reduce the total annual greenhouse gas emissions by at least 50% by 2050 compared to 2008. So these challenges are there because whatever fuel that we have been using conventionally, they are all emitting CO2 too much. So how this target is going to be achieved? One is by technical operational approaches and other by alternative fuels, switching over to alternative fuels which are more eco-friendly. So what are the fuels that we will see? Before we see that one, life cycle emissions. The IMO is investing and setting requirements for greenhouse gas from a fuel life cycle perspective. So what is this? Some emissions take place when fuel is produced, and some emissions take place during its transportation from the production point to the ship, and that we call it as well to tank emissions. And when the fuel is consumed on board, the emission takes place when it is being burnt in the engine or the boiler. That is called tank to wake emissions. So this well to tank emission plus tank to wake emission, that is the well to wake emission that is called, that is the net emissions impact. So this is what we have to aim at reducing net emissions impact, not only the emissions which are all taking place from the ship. So this is the life cycle perspective we call. So what are the alternative fuels available? LNG, liquefied natural gas, LPG, liquefied petroleum gas, methanol, hydrogen, ammonia, and biofuels. So many fuels are available, alternative fuels, but most of them, they are in research and developmental stage. So this LNG and LPG is concerned, the bunkering is available regionally. So Europe has taken the lead in LNG bunkering, making LNG bunkering facilities in many ports. Now Singapore is also becoming a major hub of bunkering LNG. For other fuels, methanol, hydrogen, ammonia, and biofuels, the bunkering is it is in the developmental stage in bunkering facilities. With so many alternative fuels available, and many of them are under research and development, the ship owners, they are not very clear about which new fuel would be the best option. So they hold off on new ship orders. So you can see in the graph, the ship orders fell by 10% in 2019 and 50% by 2020. In the last 2 decades, the ship orders have touched the bottommost level in 2020. So the reason for this slump, apart from pandemic, the ship owners are not clear which technology will pick up in future for choosing the best fuel. So by the end of 2020, 12.3% vessels on order have alternative fuel propulsion, compared with just 0.6% of the current global fleet. And in that, LNG fueled ships make up 8% of new vessel orders. LNG is a lead contender for a transition fuel as of now. Why? It is because it is readily available and CO2 emissions are lower. The LNG being mainly methane, CH4. So the proportion of carbon is less. So we expect 25% reduction of CO2 when we use LNG. That is why that is picking up as of now. But if we look at the projected marine fuel use from 2025 to 2050, we can see this is from ABS. This chart has been taken. In 2025, the oil-based fuel is usage is 95%. All other alternative fuels, what we have been talking about, they are all only occupying a 5%. And how the trend is going to change from 2025 to 2050. The oil-based fuel its use is gradually declining, and by 2050 it is expected to take a position of 40%, the marine fuel usage. So the almost 55% it is going to drop. So which fuel is going to occupy this position? We can see here this hydrogen and ammonia that is going to which is in 2025, it is nowhere in the picture, but it is expected to pick up after a decade and is going to reach almost 35% of the marine fuel use in 2050. But as of now, we can see LNG by in 2025, it will be around 2% usage, and it is gradually expected to increase. By the end of decade, it is going to occupy around 10%, and afterwards it is maintaining that 10%. There is no increase. But the hydrogen, even though it is picking up, it will start late. It will be picking up, and the other fuels such as biofuels, methanol, and LPG all put together, we can say it's around 3% in 2025, and by the year 2050, all put together, it can take up a position of 15%. And this is how the share is expected to be, because this hydrogen handling, storage technologies, they are not yet still developed, whereas the LNG it has been developed. So that is why initially we see it pick up more, and then later it is maintaining only around 10%, whereas hydrogen will keep on increasing its position. Now we will talk more about the hydrogen, then we will move on to LNG, then methanol. First, let us take hydrogen. The availability. It's a compound of either water or methane. It's produced by processing natural gas or coal, and in the process hydrogen gas and CO2 both are produced. Or it can be produced by electrolysis process of water. So this because we have recognized this potential, hydrogen's potential to generate electricity through fuel cells and combustion technology, we are going to employ them in combustion engines, gas turbines, and when they are employed, because it is not having any carbon, the carbon emission will be zero, and it can be used to reduce the greenhouse gas emissions also. If you look at the production, what is available at present in the world, there are 4 types of hydrogen in terms of the emissions released during production. One is gray hydrogen, brown hydrogen, blue hydrogen, and green hydrogen. For a colorless gas, we have given colorful names. They are all only nicknames, depending upon from where it is produced, how it is produced. The gray hydrogen means when the natural gas is processed, the hydrogen obtained, that is called gray hydrogen. During this process of production, 71 gram of CO2 is released, is emitted per megajoule of hydrogen produced. So 75% of the hydrogen produced in the world is of gray hydrogen. And brown hydrogen, it is by processing the coal, we get this one. 166 gram of CO2 per megajoule of hydrogen produced is released during the process. 23% of hydrogen produced in the world is brown hydrogen, and this brown hydrogen is produced mostly in China. Blue hydrogen, the processing of fossil fuels with the emission control technologies. When we say emission control technologies, including carbon capture, utilization, and storage methods. That means the processing of either natural gas or coal, when it is being done, the CO2, whatever is emitted, that will be captured by this methodology, and it will be stored in tank and it will be utilized. That is blue hydrogen. So if the processing is equipped with these emission control technologies, then whatever hydrogen produced is called blue hydrogen. And green hydrogen is produced by the electrolysis process of water. And even for that one, whatever electricity is required during the electrolysis, we have to feed in electricity. That electricity has to be from renewable energy sources. So sources of electricity can include solar or wind power to provide net zero carbon hydrogen production. And only 2% of the hydrogen produced in the world is of green hydrogen. So this is the scenario now. Now, if we look at the carbon release from hydrogen production, with and without using CCUS, this is carbon capture, utilization and storage method, compared to MGO as baseline. Here we can see when MGO, marine gas oil, the distillate when it is produced, is the emission is this much. It is given in gram of CO2 emitted per megajoule of MGO produced. But when we produce hydrogen without CCUS, the emission of CO2 will be this much. Is around 160 plus, 160, 170 plus gram. But when we employ the emission control technologies, the additional tubes, and when it is capturing 90% of CO2, then the CO2 emitted into the atmosphere is reduced to this way. And the natural gas without CCUS, so much emission is taking place. And when the capture rate of CCUS is 90%, it comes down to this level. And this is electrolysis process. When we are using renewable or nuclear generation, and there is no emission. That is why the green hydrogen is, it is a 0% emission. It is because whatever electricity we use for the electrolysis process, we are using renewable energy sources. And when the electricity used is from different generations like coal-fired generation, gas-fired generation, you can see it is of no use here, having so much of emission here. Okay, so this is the carbon release from various hydrogens. So the origin is important, and there is no point in using hydrogen which is produced, and that is what we say it is well to tank. That time itself, if the emission is more, there is no point in having it on board and claiming that it is emitting zero CO2. Coming to properties of hydrogen as compared to conventional marine fuels. The conventional marine fuels, MGO and HFO properties are given here. The boiling point is 180 to 360 degrees centigrade, MGO and HFO. But the boiling point of hydrogen is minus 253 degrees centigrade. That means you can imagine to store as a liquid how much energy we have to spend. And the liquid density, here it is 900 kilogram per cubic meter and 991 kilogram per cubic meter, whereas hydrogen is only 70.8 kilogram per cubic meter. And the calorific value, megajoule per kilogram, is 42.7, 40.2, and this is 120.2. This is, you can say, per kilogram, the heating value is the highest, 120.2. But this liquid density is too less. And these two both multiplied together, liquid density and lower heating value, because these two are going to decide how much space it is going to occupy for certain amount of energy carried on board. So even though this is 3 times more, we can say this one is only 1/14 of this one. So that means the net result is for certain energy to be carried on board, we have to allot more tank space. That means cargo space will be reduced in the ship. And the auto ignition temperature is 250, and this one is 585. It is very important when we inject the fuel at the end of compression, it has to catch fire automatically. So that means the auto ignition temperature of the fuel has to be less than the temperature attained in the cylinder at the end of compression. Otherwise, it will not catch fire. So this temperature is more. So unless an ignition source is given, it will not catch fire on its own. So that is that. So that is why we are going in for the dual fuel model, etc. When we are going to use hydrogen, so it cannot fire on its own. Flash point. This has to be as per the regulation, minimum 60 degrees centigrade and 60 degrees centigrade. But this flash point, it can flash in any temperature above minus 253 degree centigrade. So that is, more fire prone, very dangerous. Energy density. This is when a spark is given. Energy density, that is given in megajoule per liter, is 38.4. 1 liter of MgO, it will be giving 38.4 megajoule, whereas this one is 39.8. And the hydrogen, it is only 8.51. It is because even though per kilogram it is more, because the density is less, that is why we get this figure. That is when it is stored in liquid form. But the hydrogen gas, when it is as a gas at 700 bar pressure, when it is stored, this will be 4.8. It is further less. That means the volume requirement for same energy, it will be more when we are taking in gas mode. The compared volume to MgO for this is 1. This is we are comparing the MgO only. So that is why it is 1. This means it is 0.96. And this one is 4.51. That means when you are comparing it with the MgO, you will have to, for the same energy, you have to carry 4.5 times. You have to allot 4.5 times more space. Otherwise, the bunkering will be more frequent. And when we are carrying it in gas form at 700 bar, then it is almost 8 times more space is required, same energy. So that is a property. And another property is lower explosion limit and upper explosion limit. And MgO, it is 0.7 and lower explosive limit, and UEL is 5% volume fraction. So this is over a smaller range, it is explosive. And HFO is also from 1% to 6%. This is also a smaller range. But the hydrogen LEL is 4% and UEL is 75%. It has got a wide flammability range, so the fire risks are more. And matching power generating systems with the fuel. We talked about 4 power generating systems: IC engines, gas turbines, steam turbines, and fuel cell. And the MgO is concerned, it is compatible and readily applicable in IC engines, gas turbines, and steam turbines. HFO is also readily applicable in all 3, but in fuel cell, it is compatible in principle, but it is under research and development. So it is not yet ready. And whereas hydrogen, as of now, fuel cell, it is readily applicable, but in IC engines, gas turbines, and steam turbines, it is compatible in principle and it is under research and development. Even though the first hydrogen powered vessel, which was a ferry, passenger ferry of 15 to 16 seater capacity, it is having hydrogen engine, is a dual fuel engine. The hydrogen is carried in tanks, They don't bunker. Usually the hydrogen will be, how it will be developing, it will be given in tanks. It is like how we take LPG cylinders at home. It will be delivered in cylinders. So similarly, there in that vessel, which was released at the end of 2017, hydrogen powered. They have got the engines, dual fuel engine. Hydrogen is fired along with the pilot fuel of diesel. So they carry 12 tanks of 205 liters capacity each, and 2 tanks of 205 liters capacity for diesel fuel. So they are, but they are all under research and development. Only as of now, hydrogen can be used only in fuel cell. So what are the benefits of hydrogen? Is a carbon and sulfur free. It can be produced renewably from electrical energy and biorenewable processes. Can be stored and transported as a liquid or gas. So there it is a 200 liters, 205 liters a tank. They are taking as a gas form only at a 200 bar pressure, not as a liquid. Established commercial product on land. There is no emission as far as the fuel cell is concerned. How the fuel cell works, it has got anode, cathode. In the anode, the hydrogen is passed. In the cathode, the oxygen, the air is passed. So here in the anode, the hydrogen splits into electrons and protons. And these electrons pass through the outer circuit through the load, and the protons, they pass through the electrolyte straight away into the cathode, and the end product is only water, the heated water. So there is no gaseous gas release in fuel cell. Highly buoyant and disperses if leaked even at liquid hydrogen temperatures. And it's a zero carbon marine fuel when it is used in a monofuel IC engine. But when it is blended, the hydrogen fuel blends are also used. It is blended with even LNG. It reduces exhaust gas emissions and greenhouse gas footprint, and it's co-combusted with the diesel fuel also. It reduces NOx emissions. The highest energy content per mass of fuel, and it is non-toxic. And the challenges, as we have already seen, more space requirement. The more space requirement is due to lower volumetric energy density, as well as due to it has to be stored at minus 253 degrees centigrade. That means the insulation and other things, the vacuum insulation and the layers of materials surrounding the tanks, adding again the space requirement. The fire hazard is concerned, the wide flammability range, and this range increases further when it is mixed with the pure oxygen, and the ignition energy required is very minimal. It is only 0.02 millijoule and quickly forms flammable gas. Another disadvantage is, it builds up electrostatic charge when it is, when it is passed through the pipeline, or when it is agitated, electrostatic charge is developed, and all hydrogen handling equipment is to be protected from electric charge buildup. And the flames are invisible. That is another challenge. Burns quickly with a maximum speed of 3.15 meters per second, and the contained areas are susceptible to fire hazards. And whatever compound or the gas which can come in contact with this lower temperature can liquefy or solidify, and the human contact with the cryogenic materials or uninsulated tanks pipes. It can cause cold burns also. The material challenges, they require thicker insulation. The thick insulation requirement is 3 times more than what is required in a LNG Type C tanks. Vacuum insulated Type C tank can also be used. And the gas is capable of dispersion through materials. It can penetrate into the walls of containment systems and permeation into certain fluids also, and should be stored in appropriate materials that minimize the permeation. Another material problem is hydrogen embrittlement. It occurs when hydrogen is absorbed by a metal and collects at grain boundaries. It creates cracks, and it is creating weak spots within the material, and further it can lead to leakage. The other challenges with the hydrogen are the high energy input required for liquefaction, and it can act as a asphyxiant. Even though it is non-toxic, it can act as a asphyxiant. Low availability, only 2% renewably produced hydrogen, green hydrogen in the world. High cost, transportation infrastructure, a lack of marine transport experience. We don't have the experience of carrying in the tanks. Liquefied hydrogen tanks at low pressures can be susceptible to pressure buildup if temperature rises. And a lot of investment is required for bunkering infrastructure. And the technology development, it requires a lot of cost. And for that, the policy changes are required from the governments. High explosion risk in confined spaces, and NOx emissions if used in IC engines, because this NOx nitrogen is coming from air. So these are all the challenges in adopting hydrogen as fuel. Now with that, I would like to ask any questions from the side, because next we will move on to LNG.
Audience, any questions on the covered topics? Professor, what are the challenges for this fuel cell for practical usage?
Actually, the voltage produced is less, so we have to combine many cells, and again the occupancy, the space occupancy for the bigger vessels and all whatever required. Actually, there are various types of cells depending upon what fuel. Apart from hydrogen, they have developed using other fuels such as methanol, ammonia, and other fuels are also under consideration. But main thing is the voltage is per cell, it is 0.7, 0.8, certain cells 1 volt. So they are all to be combined in series to get whatever voltage required. And that is the main concern, sir, as of now.
Yeah, a lot of R&D work is going on for last 2 decades.
Yes, sir. Yes, sir. Yes, sir.
On hydrogen fuel cell.
Yes, sir. But finally, it is going to take over, sir. That is what they expect.
Yes, sir. As of now, there is no much improvement. Nearly about 10 years, very little amount of improvement only on hydrogen fuel cell.
Yes, sir. Yes, sir. But the improvements are there. Like, they have started using reformers within the cell. So there is no need to give only hydrogen. Even suppose if we are using ammonia, there is no need to separate hydrogen and give it. When we feed straight away ammonia, it takes the hydrogen. So the improvements are there, sir.
Any questions from audience?
Sir, there is a question in the chat box.
Yes,
from Mr. Durai Pandian. Auto ignition temperature, why it is high in hydrogen? Even if I have less flash point.
Yeah, it is, it is not interdependent. The flash point and auto ignition temperature, certain fuels will have more auto ignition temperature, less flash point. And there is no correlation between these two.
And one more participant, he has asked whether the same engine is utilized for the AF. I don't know what engine he is referring to. Whether the same engine is utilized for the AF.
That is alternate fuels.
Yeah. No, same engine means which engine?
Actually, the MAN, this ME engines, ME, GI. GI means the gas ignition. So there the ME engines of MAN, and they do only little bit of modifications, and they are using it, but not for hydrogen. It's all under research and development only, but the other gaseous fuels. But the pilot injection will be there. The pilot injection means around 1 to 5%. In some engines, they use 1% of diesel oil. Every time the diesel has to be injected through the injector, it will catch fire. Then only and the other gaseous fuel that will catch fire. And this amount of diesel injected, because why we are replacing diesel or HFO, it is to reduce the emission. So this 1 to 5% which is being injected as pilot fuel, that will contribute little bit of emission that we cannot stop.
Good afternoon, sir. My name is
good afternoon, sir.
Durai Pandey.
Good afternoon, sir.
From CMC. So my question is, as you said in the emission control standard, if you use and if you control the carbon, if you use emission control standard, then we can control the carbon while extracting. So how they will control this? What are the methods they are using over on this emission control standard, and how they are taking this carbon, CO2, how they are using it? As you said, it is used for various applications. It is used. So where it is used, how it is used? Can you explain about that, sir?
I think it is again for carbon is again fuel only, and that will be again utilized. So, but it is in marine industry. It does not, it is not yet. Actually, the technology is only in the, as I mentioned, this hydrogen which is produced. It is negligible in the world, but they have mentioned about this technology, and what they say, it has to be, if it is to be applied in ship, it has to be just captured, stored in tanks, and when we come to shore, it has to be given to the shore reception facilities, and probably that is again recycled.
Sir, there is another question from one Mr. Venkatraman. What are green ships? Do green ships use alternate fuels?
The green ship means, as we said, the green hydrogen, green ship means the emission free ships. Whatever we are talking about, mainly the CO2, greenhouse gases, and other SOx and NOx emissions. If there is nothing, then we can call if the solar propelled ones or wind propelled ones. And in case the hydrogen is used, that is also because there is no emission. So these are all the green ships, wherever the emission is kept to a minimum.
Sir, Durai Pandyan again, sir. Sir, I have another question.
Yes,
Sir,
sir.
since engine room and the pump room is separated because of this hydrogen gas only, it has been separated.
Yes, sir.
Engine room and pump room is not. So, if you use an hydrogen as a fuel, there is a lot of safety measures we want to take, and we want to educate the crew members, and there is a lot of steps has to be taken, and safety concerns also has to be
Yes, sir. That is
taken to be
addressed
more.
by IGF code, sir. The vessels which are utilizing gas as fuel are the low flash point fuels, because the 60 degree centigrade is the flash point limit set by the solar for the fuels in use in the engine room. If the temperature is the flash point is less than that, then the application of IGF code comes, and the international code for using gas or the low flash point oils, low flash point fuels as a fuel. When we are utilizing that one, so there they talk about the crew training, etc. Crew training, the design, the operation, and the construction. Everything is taken care as per the IGF code.
Okay, sir.
Sir, any of you, if you want to add to my answer or correct my answer, you are free to correct, sir.
Copied, sir.
Any other queries from participants?
If no other queries, we can continue our presentation.
Okay, sir.
Yes, sir. Please proceed.
Thanks, sir. This LNG is a fuel for fossil source only. Biomethane is a renewable natural gas. It can be produced from the waste from landfills, livestock, etc. through anaerobic digestion. It's a mixture of several gases, but mainly it is methane. The concentration can vary from 70 to 99% by mass. Other constituents might be ethane, propane, butane, etc. But we want this one to be kept maximum, because here when we go to ethane, propane, butane and all, the carbon content increases. So small amounts of other gases such as nitrogen may also be present in LNG. So how much is the reserve? The International Energy Agency estimates the reserves at the usage rate in January 2011. They can come for another 250 years. But when the usage rates increases again, this period also will be coming down. When liquefied, the volume required for natural gas is reduced to about 1/600th. It is stored in tanks where the heat ingress leads to the generation of boil-off gas. So this boil-off gas is consumed by the engines or is re-liquefied in order to maintain the tank pressure within the limits. And the properties of LNG, it is minus 161, the boiling point. So compared to hydrogen, it is less. And it's more. The density is 430, is compared to conventional fuels, is of close to. The lower heating value is 48 megajoule per kilogram, and the auto ignition temperature also is high. So this also, as a monofuel, is you cannot. You have to use another pilot injection is required of diesel. The flash point is minus 188 degrees centigrade. The energy density liquid, that is per liter of the fuel, how much energy it is possessing. It is only half of this HFO value. When we say half, that means for the same energy to be taken in the ship, 2 times more space is required, is around 1.86. But we have to consider again the insulation requirements. Because of the insulation arrangements, the space requirement will further increase. And LEL is 5.3 and UEL is 17%. This is okay. The range is around 12%. Still okay compared to and the carbon dioxide emitted in grams per megajoule of energy produced. This one is 69.22 and LNG is 50.3. So if we look at these two figures, we can say it is around 25%. It is less. That is what we can achieve. But main thing is they want to reduce. Whatever be the means, it has to be reduced. Even if it is little bit also, it is going to matter. And the matching power, the LNG is concerned, IC engines, it is compatible, readily applicable, it is under research. So already it is applicable in IC engines. And in gas turbines and steam turbines, we have been using it. It's readily applicable. And in fuel cell also, it is compatible, readily applicable, it is under research. So that is so it can be, that is why it is a leading contender as of now. It meets regulatory requirements. There is a benefits. And the LNG fueled vessels can reduce their EEDI, energy efficiency design index rating, by 20%. Methane has less carbon bond. Eliminates SOx, particulate matter, because sulfur content is less than 30 ppm in LNG. And greenhouse gas emissions can be reduced by 23% with modern engine technologies. So, but to capitalize on these benefits, the technology that fits the vessel type and operational parameters is to be chosen. Okay? So that means whatever, because the vessel having this boil-off gas management equipments will be there, and because the consumption of the boil-off gas is very difficult, even though during the design stage they take into consideration where the vessel will be plying, what are the environmental conditions, what the atmospheric conditions, how many days it will be sailing, how many days it will be at anchorage, and port stay, how many will be there. Because during the design they have to match this try to match this boil off gas, how much it will be. Accordingly, the they have to design the tanks and other things. So there is no requirement for other boil off gas management equipments for reliquefaction or for cooling purpose. And the LNG bunkering infrastructure is continually improving with the fuel already available in most major shipping hubs. The leak of LNG to the outside of the ship will not be the polluting event. That is another advantage of this one. Relatively safe because its specific gravity is lighter than that of air and it easily diffuses and there is less risk of explosion. But even after liquefaction, LNG still cannot match the energy density of oil fuels that we have seen. It requires almost 2 to 2.5 times more space than the oil fuels. And another challenge is the methane slip, which is methane slip which can occur in engines without burning. The methane is escaping along with the exhaust. That is another challenge, especially at when the engine is running at lesser loads. The methane slip will be more. And when it happens, it is doing more harmful to the environment because the global warming potential of methane is 28 times higher than that of CO2 over a 100-year perspective. So the concept of bunkering is new to most owners, although it is familiar with the LNG, LPG cargo community, but for the majority of the most owners, of the ship owners, this concept is new. And the operational issues will have a major impact on ship design and construction. So they have to take into account the operational issues. And the fuel containment systems. There are 4 main types of LNG tanks. One is the independent tank type A. The other one is type B, independent tank type C, and integrated membrane tanks. In this, the independent tank type A, type B, and the integrated membrane tanks, they are all of low pressure, whereas the tank type C is a high pressure. And the barrier, again, the secondary barrier is required surrounding the tank, and that secondary barrier is complete in case of type A tanks. It is partial in type B tanks, and type C tanks are concerned there is no secondary barrier, and these type C tanks are preferred in most of the vessels. It simplifies the required boil off gas management procedures and equipments. And the integrated membrane tanks, they need a full secondary barrier, but the integrated membrane tanks, that will be preferred by vessels which are going for longer voyages. So to limit the loss of cargo space, these integrated membrane tanks are preferred by these larger vessels. But due to rolling, the sloshing can be an issue in these membrane tanks. The design of the LNG fuel containment system needs to consider both the optimal operating profile and the undesirable conditions, such as when the vessel stops, loads, awaits orders, etc. And the boil off gas management equipment. The IGF code permits a number of ways to manage the BOG. One is by consumption, other by reliquefaction, the third one by cooling, and the fourth one is pressure accumulation. So the code sets criteria for controlling tank pressure and temperature at all times, for maintaining the tank pressure within the limits, so that it is below the relief wall setting for 15 days when the vessel is idle with the domestic load, because during that period the consumption is not there or reduced. So the for 15 days idle period, the IGF code sets the criteria. But in actual case, in many vessels, the 15-day criteria can the okay 15-day criteria, it may be difficult for atmospheric tanks to achieve on domestic load only. So the other equipments, by consumption alone, this pressure cannot be maintained within the tank. So other equipments are needed for reliquefaction, because this as of now, an Aframax tanker in the European sector, it spends 30% of its time idle with no main propulsion power, and it moves also at a lesser speed than it is designed for. Similarly, the ore carriers, the bulk carriers, they spend about 3 weeks in port waiting to load, and about another 3 weeks waiting for discharge. So the system design is they have to consider all these things. That 15 days period, as said by IGF code, that is not sufficient. And as of now, in 2010, the 18 LNG vessels were there, and 175 currently in service, and more than 200 on order in 2020. And most of these vessels are operated in Europe. So, and the Japan's first LNG fueled tugboats have also been launched. Similarly, 9 LNG fueled container ships of 23,000 TEU. The order has been placed by CMA CG, the French container shipping company. They have placed the order with the China shipping industry. So these vessels are scheduled to begin their service between Asia and Europe. So once they bunker in Europe, they have got the facility, so much of bunkering they can do. They need not do any bunkering when it comes to Asia, and they can go back to Europe without any bunkering in between. And most of the LNG fueled vessels, they are all operating in Europe, and the size of the vessel is also getting larger. The emission controls areas are also expanding, and the demand for LNG is increasing. It is expected to grow to 30 to 50 million tons per year by 2040. So as far as the bunkering facilities are concerned, the port of Rotterdam, Amsterdam, Zeebrugge, Barcelona, and all other major ports in Europe, they have got the bunkering facilities. And Sweden and Finland, which are in the Baltic Sea region, they are also developing fuel supply vessels. The world's largest LNG bunkering vessel is Gas Agility. So the Singapore has also developed a major bunkering facility for LNG. Coming to the engine developments, the MAN's MEGI high pressure dual fuel engine is a GI concept, that is a gas injection concept. It is an add-on concept to the existing ME engine. So the ME engines are gas ready, and the diesel cycle is followed in both oil and gas modes, where the gas is supplied to the engine at high pressure of 300 bar. The fuel gas supply systems involves high pressure pumps, evaporators, and high pressure compressors. And this engine is a Tier 3 NOx compliant in gas mode. The liquid pilot at 30% MCR is 3 to 5%, and there is no methane slip as far as this engine is concerned. And there is another engine, WinGD, and that is gas and diesel dual fuel engine. This is a low pressure engine. To this engine, the gas is supplied at a low pressure of 13 bar. But this one is auto cycle when it is in gas mode, but when it is in oil mode, this is a diesel cycle it is following. So this because low pressure, the fuel gas systems, it is involves low pressure pumps, evaporators, and low pressure compressors. The Tier 3 NOx compliant in gas mode, and the liquid pilot at 30% MCR, it consumes only 1%. Compared to the MAN engine, this percentage is less, and but methane slip is there because of methane slip, especially at lower loads, it will be more. That possibility is there. Apart from that, the NMAS auxiliary LNG dual fuel generators operates at a mean effective pressure of 20 bar. Wärtsilä also has developed auxiliary generators which operate at a mean effective pressure of 21 and 27 bars, 20 DF and 31 DF auxiliary generators. The emission concentrations, comparing with the diesel HFO, when it is on one engine we talked about high pressure, that is the MAN engine, and that WinGD we talked about low pressure engines. The NOx level is compared here with the HFO and the diesel fuel. We can see here the NOx is reduced so much, the SOx, the particulate matter, and this is the CO2 reduction. Anything related to LNG, or shall I move on to biofuel and then we will ask?
Anybody wants to pose questions on LNG? So I think we can continue on biofuels.
Okay, madam. And this biofuel, there are like how we have got hydrogen, plenty of varieties depending upon the origin. Here, the liquids or gases derived from biomass or bio waste. The various biofuels are available: fatty acid, methyl ester, hydro-treated renewable diesel. The feedstock is soybean. Fischer-Tropsch diesel. These are all various processes. And here the feedstock is forest residue, dimethyl ether, biomethanol. So various biofuels are available. And animal feedstocks are also used. Rendered beef, poultry litter, other animal fats. And the used cooking oil also used to produce the biodiesel, biofuel, which is called UCOM. So used cooking oil, methyl ester. So this fuel, the advantage is it can be drop-in fuel. Drop-in fuel means the modification required to fuel storage transfer systems they are not required. Whatever systems we have got at present for the oil fuel, they can be used straight away. And unblended fuel replacements, and they are called neat fuels. The drop-in fuels have non-toxic biodegradable properties and reduced greenhouse gas emissions. The total carbon reduction potential of biofuel depend on source of feedstock, like how when we discussed about hydrogen, the CO2 emissions are different from different sources. Here, the carbon reduction potential of biofuel, it is depending upon what is the feedstock source, the production pathway, what production methodology is used, and the slips, fugitive emissions during the transport and other things, what slip taking place during the production as well as the transportation. And coming to well-to-wake life cycle SOx and greenhouse gas emissions per megajoule of fuel combusted for marine applications, we can say this is a SOx emissions, this is greenhouse gas emissions. It is given in grams per megajoule for the residual fuel, and this is for the marine and the various types of biofuels. When we say biodiesel B100, this is a neat fuel. Neat fuel means it is not mixed with other fuels. When we say B20, the 20% is biodiesel mixed with the 80% marine distillate, and that is B20. So they have compared what is the well-to-wake life cycle SOx and greenhouse gas emissions. And here this color, the well-to-tank, they have given separately. This is tank-to-wake. Tank-to-wake means when it is combusted. So when we see here the Tropsch, Fischer-Tropsch diesel, hydro-treated renewable diesel here, when it is combusted in ship, the emissions are zero. So actually whatever little bit, that is well-to-tank emissions, that is during the production stage and the transportation stage up to the supply, up to the ship, only that little bit emission is there. Otherwise, they are all clean fuels. And coming to the greenhouse gas emissions, they have given grams of CO2 equivalent. They have made it grams of CO2 equivalent per megajoule. Here we can see the well-to-tank. Well-to-tank, it is going in the negative side. Why it is going in the negative side? Because when the plant is various sources we have seen, soybean, and in India we use jatropha, etc. So this during the production, it is absorbing CO2 from the atmosphere, and that is why it is in the negative side. So we have to take that one also into consideration, and that's why it says life cycle emissions, right, from production till it is consumed. And this is we can say the red one is tank to wake. And finally, what is the net emission? Well to wake, that net emission is only this much. So in the Fischer-Tropsch diesel is the least, and these are all various biodiesels. And anyhow, compared to residual oil and marine distillate, the total greenhouse gas emissions, it is far less in biofuels. The advantages are low sulfur emissions, low particulate matter. It meets the most stringent IMU SOx limits without any additional fuel additive. There is no need for any after treatment. There is no need for any additive. It makes use of the existing fuel transport and bunkering infrastructure. Many biofuel blends can be used without engine or fuel system modifications, and it provides logistically and economically attractive solutions. So when produced from renewable biomass, it is counterbalancing the combustion emissions that we have seen during the production stage. It is in the negative side, that's absorbing the CO2 from atmosphere. Eliminate the need for expensive new infrastructure, and diesel is generally considered combustible with a flash point between 52 and 96. The flash point of biodiesel is greater than 90, so it is less hazardous. And the lubricity characteristic it has got, so it can improve the performance of the engine as well as it can reduce the fuel consumption. Biodegradable, that is in case of spills, not to read too much. When biofuels come in contact with water, they quickly begin to degrade and disperse. So the biofuels, the blends, the biodiesel all have similar properties. Regarding the boiling point, sorry, I could not get these boiling points and other details. But the lower heating value is concerned, it is maybe we can say it's around 20% less than this MGO, but this is hydro-treated vegetable oil. This has got more than MGO. And this is also a biofuel. This is not HFO. This is hydro-treated vegetable oil. And the energy density, the amount of volume required to carry for the same energy, we can say it is only as comparable with the MGO. It's more or less the same space is required. That is the advantage of this fuel. So this, as far as the IC engines, gas turbines, steam turbines are concerned, this fuel can be used in all IC engines, gas turbines, steam turbines. But coming to the fuel cell, it is compatible, but compatible in principle, but it is under R&D. Otherwise, this fuel can be used in all the engines. But it has also got some challenges. Even though the biofuel, we said that when it is spilled into the water, it degrades. When it is spilled into the marine environment, it behaves similarly to marine fuels until fully degraded. So, still a spill recovery mechanism as a cleanup practice has to be followed. Some biofuels will burn if ignited. So, the isolation requirements in the manifolds, the ventilation arrangements from oxidizing agents, and keeping the ignition sources away from the ventilation points, etc. All those are to be followed, and that is as we follow in the HFO and diesel oil tanks. System corrosion of certain materials due to fuel acidity. Corrosivity depends on concentration of fuel and what the feedstock is, whether the water contamination is there or microbial growth is there. So it can corrode the material. And the deterioration of rubber, copper, brass, lead, tin, zinc, these components can occur. So the material chosen accordingly as to what grade of fuel being used, what is the feedstock they are using. Accordingly, the material must be selected. And when water is present in biofuel, bacterial and fungal growth can occur, which can cause a degeneration of oil. And biocide or antimicrobial additives have to be added to stop this process, the degeneration of oil. But when water is not contaminated, it can be stored even for 3 years. With the high oxygen content, can also deteriorate naturally over time to form insoluble contaminants. So it has to be used in a timely and regular manner. At low ambient temperatures, certain biofuels tend to cloud and gel. If the temperatures cannot be kept above the cloud point, the anti-gel additives, they are available, they can be added. But the main problem with the biofuel is the availability challenge. So the biofuel feedstock is limited because it has got needs in the agricultural sector as well as in the automotive sector, and aviation industries also are using. So it has to be produced on an increasing scale to support uptake in the global maritime fleet. The different feedstocks are used in different parts of the world. Rapeseed oil is used in European Union. Soybean oil is produced in the US and South America. Palm oil is produced in Southeast Asia. Distillers corn oil is produced in the US. But for the necessary substantial increase in production, the influence from the governments, the policy changes, they are all required. Otherwise, the requirement to fulfill these units, these agricultural, automotive sector and aviation industries, there itself the demand is more. Another challenge is the cost. It is more expensive than MGO and MDO, HFO. And the price is subjected to the production. And the production is depending upon various factors. It is depending upon the geography, the genetics, the soil fertility levels, and the regulations, the tax being levied, the labor cost, etc. So the cost is another important factor. The feedstock cultivation, transportation, and densification. They do the densification for processing, and the storage and the pre-treatment process. There the cost is going very much high. If biofuels increase as an energy commodity, the competition of biomass feedstock with other sectors, it can result in an increase in the overall price. So that is there. But another disadvantage with this fuel is it has got detergent properties. Suppose if you use the biofuel after usage of some other fuel, what can happen? The suspended deposits left from marine petroleum fuel, it can be washed and it will go and clog the fuel system. That is the disadvantage of this fuel. So it has to be used carefully, especially when we use the same system after usage in other fuels. When we are using biofuel, because it has got the detergent properties, we have to be careful. The filter cleaning and other things we have to take care. And this is the availability in various areas. The Europe again is the leader in the production of biofuel. Various parts of Europe, they use various feedstocks, sunflower, linseed, etc. Then comes the North America, then the South America, Indonesia, Malaysia, and India, Africa, and other, all put together, it is only just 1.5. billion gallons in 2020. A year, the main feedstock is Jatropha and Pongamia. Ammonia. Coming to ammonia is again, this is the one, ammonia and hydrogen, they are going to make the lead. Even though the takeoff will be little later, hydrogen can alternatively be carried within other substances such as ammonia or methanol. It requires less energy than that needed to refrigerate or to compress gaseous hydrogen. So the also be used in some fuel cells by reforming and extracting hydrogen from the fuel using internal reformers. These reformers, either it can be externally it is done, or some of the fuel cells and they have got the internal reformers also. So it can be fed into the fuel cell also. But these technologies, they require higher energy input to hydrogenate and reform the fuel. Less efficient electrical production than pure hydrogen. So only when pure hydrogen is used, there the efficiency is more. But here, compared to that one, efficiency will be less. And here, the boiling point is a minus 33. So comparatively, compared to LNG and hydrogen, it is much more. The density is also comparable. We can see around 25-30% less than this. The heating value is only half of this. The auto ignition temperature is again high, 630 degrees centigrade. That is why we have to realize how comfortably we have been using MGO and HFO for so many years. When we look at these things, we will be having complicated systems to handle, store, etc. The flash point is 132. And again, the compared volume to MGO for the same energy. So this has to be, again, the volume requirement to carry this fuel is around 2.5 times more. LEL and UEL is 15 and 25. So it's okay, 10% the flammability range it has got. Coming to the applicability of ammonia, with the gas turbines, steam turbines and fuel cell, they are all compatible, readily applicable under research, but still in IC engine, it is compatible in principle, but the research and development is going on.
Any questions from audience?
So I'm Gopal Krishna here from Mumbai Port Campus. Hydrogen and ammonia have many challenges, and it looks like LNG comes where in between. So why LNG is not picking up the way it is expected?
No, it is picking up, sir. It is as of now it is picking up almost 8% of the ship orders as of now. It is they have ordered LNG fuel vessels.
But going forward also, hydrogen is supposed to pick up, but not LNG. But is it a wish list that hydrogen should occupy that much percentage, or it's a reality?
No, it is
real estimation.
No, it is based on the research, development, etc. going on. These all the data, whatever I have taken, it is all American Bureau of Shipping. Whatever the white paper, the sustainability white paper submitted on various people, various fuels, and these were submitted in this year, current year, not whatever
Not very old.
are not old ones.
Okay.
And
Thank you.
Any other questions from audience? Thank you, sir.
Thanks, sir. Thanks, sir.
You made this session is very interesting and wonderful session.
Right. Thanks, sir.
You prepared a lot of material. Thank you. Thank you for
Thanks,
your kind support.
sir. Thanks for the opportunity given. And
Thank you, sir. In your
I really enjoyed it, sir.
Yes, sir. In your busy schedule, you have allotted nearly about 2 hours for us, only for presentation.
Okay.
Thank you, sir.
Thanks, sir.
That to post lunch session, you made all the participants awake.
That was
another interesting point.
That was a challenge for the presentation.
Yes, very interesting presentation, sir. I
Thanks,
really
sir.
enjoyed.
Thanks, sir.
Thank you, sir.
Thank you very much, sir. Thank you
Thanks.
very much, sir, for
Thanks,
an
madam.
excellent presentation.
Thanks, madam.
This is a very appealing topic to the majority of the participants, as many would like to conduct research in this area.
Yes.
You have provided useful information about the subject. Your
Oh.
presentation style was also excellent and perfectly poised.
Actually, I would like to show the references what I made. Is it the screen is still shared or no?
No, sir, not shared.
Oh, 1 second. These are the reference materials.
Yeah. Yes, sir. So noted, sir. Noted the references.
Oh, okay. Thanks, madam.
Thank you, sir, for your time and knowledge sharing. Thank you.
Thanks, sir.
Participants, we have given the attendance link for today along with feedback. Please fill the form and submit. Tomorrow we are joining for actually session number 7 by 10 o'clock. Use the same meet link for joining. Thank you very much. Thank you to the guest speaker and all the participants.
Thanks a lot for all the dignitaries present here, and I enjoyed, and whatever knowledge I gathered, I have passed on. If anything is left, you can you can inform me.
Thank you, sir.
Thanks, sir.
Thank you very much.
Thank you.
Participants, we can meet tomorrow morning 10 a.m. Thank you all. I hope you enjoyed the 2 days. Total, we have completed 6 sessions. I hope all of you enjoyed. We'll meet tomorrow at 10 a.m. Thank you. Thank you all.
Yes, sir. Thank you so much, sir.
Thank you, sir.